Streamer might have found a bug. What was it? What was it? I'm sure it wasn't a bug. There's no bugs. Like if you don't give the if statement something to do, it still compiles. What do you mean by don't give it something to do? Like if without a, oh, like this? I believe that actually. Right? I bet that works because this is a common mistake. No? What do you mean then? Lose the braces. Just like if, like that. I mean, let's see what happens. We probably shouldn't allow that, it's true. All right. So keyword if. Yeah, so we definitely, whoops, that's the wrong one. That's static if. This is dynamic if. Okay. Problem is, we're going to have some ifs in the preload. This is line 2. All right. That's the wrong one. This might be the right one. Probably not. How is there only one if? Oh, because the imports are going to come in later. All right. So we do a parse block. Braces are optional, which is yes. Braces are implicit is probably no. Pre-existing block is null. So, okay. Here's the thing. Because we're kind of loose about parsing a block, like, hey, it could be a one statement block where you don't need braces. I mean, a lot of languages do that, right? Or you could use braces. What am I trying to say? So basically, we're going to come back from this. If I step over this, we're going to get it back a block. Because this creates a block, but it's an empty block, right? So like, we could do something where we say, well, let's try again. Because maybe we should modify. Whoops. Maybe we should modify parse block to avoid this, broadly speaking. So we could say if braces are optional, we need to have parsed something. Of course, there might be some expressions that are totally optional. I need to think about that. Okay. So basically, we're going to call like parse statement. Oh, we don't even get there because we see that we're at the end right here. Okay, let's just put a thing here. If braces are implicit, oh, we need parens. Those are not implicit. Oh, no, optional. If not results, statements dot items, report. I mean, the problem is we already ate the frickin' token. Oh no, because we peek it. Expected a statement here. Just say that. We're just going to say that. Oh yeah, this count. This is, I don't know what its problem is there. Oh, report parse error. That's what I want to call. I don't know why I passed the Lexer. Okay, so the problem is that's not a very good thing to highlight. right? And then X. What are so many windows? Somebody help with all the windows. God. I should just do this. I should relearn to do this. All right, so I mean, we'll just leave that for now. We'll make sure we didn't cause problems. How's that? Lol. See, I told you there would be something. Although that shouldn't be. Why are we parsing a block in that case? That seems very weird. Shouldn't we be doing parse expression? See, sometimes you're just going to do something simple and it takes like an hour. And then you don't want to talk to chat anymore after that hour because they put the wrong answer on the poll and everything. Wait, the poll disappeared, man. Is it over already? What's the answer? View results. I mean, the crowd has spoken. I don't know what to say about that. Okay. Expected a statement here. Wait, it said that there as well? What? Oh, because it's before the... Okay. Yeah. No, it's here. See, okay, that's actually legal. It's not actually this. I saw this and I said, oh. So first of all, instead of here, like this is really annoying because it's like now we need like yet more. Oh, we're going to hack it. We're going to hack it, baby. That might not be the only case is the problem. Let's see. Debug compiler, please. That's weird. Oh, no, because braces were optional, but we got them anyway. Which we have a flag for that. Its braces are optional, and we got braces. Because you can have an empty block with braces. That's allowed. Right, so you can have an empty block at top level scope, and that's legal too, isn't it? Imperative because in a global scope, empty block is allowed. Empty file, bro. Okay, we're getting there. We're narrowing in on what exactly we want to permit. Okay. Okay. Let's see if the tests have anything weird. As soon as my water reboils again, I'm going to pour some tea, man. Parser fixed. The parser accepting empty, what do you call it? Zero length statements for things like the then block of an if. All right. That's quite okay. How's it going, everybody? Feels like I'm going to ship a beta tonight after the stream's over. I'm going to have a real nice tea in a minute because we have milk again. Milk again. So I thought what I would do next is make just a little bit of an architectural change in the compiler, not a big one, because we want to work toward, you can't just be fixing bugs all day or you're splashing and not swimming, right? So we want to work toward progress. And what I felt like would be good to do is change the way bytecode instructions are stored, because that will, the way they're stored right now, is a little bit inefficient because they're, again, just in a packed linear flat array, and we keep adding them and stuff, so we keep doubling and copying the array and all that, and that's not great. However, it's not the worst thing, because even in the Sokoban game, there's only like, oh, we don't print it in release. Hold on. We do print it in debug. We say how many bytecode instructions were in the whole game, and it's like 400,000, as I recall. Not that 400,000, though. There we go. Oh, 440,000. Sorry. Yeah, that's 40,000. It's about 400,000. So, you know, I forget how big each of these is. Let's go look. It's not small, but it's smaller than it used to be. So here's the struct for it. And like this is probably 8. So this is probably 64 bits, right? And then 64 bits, and then 64 bits, and then 64 bits, right? So it's 32 bytes times 440,000. You know, so it's 14 megabytes. It's not super fast to have to copy that more than you need to and stuff. I don't know how many times we would copy that on average expanding arrays, but I assume it's approximately once probably, right? So we copy an extra 14 megabytes that we don't have to, which seems like a lot. On the other hand, you can't load a web page in 14 megabytes nowadays. So it's like, it's not the worst thing, but then also the web is slow, right? So that's one aspect. The second aspect, though, is you might have seen if you watched the earlier stream today, you know, sometimes when we set up branches, we do a lot of stuff. And because, again, we have this thing where the bytecode instructions might move around, we can't do the thing that we want to do, which is just like get a memory pointer of the instruction and then jam the thing in there when we know it. We have to like get an index and then later get a pointer from the index. It's just a little bit more annoying than I would like. So there's fixing that along with this. And then, assuming that goes well, I don't know if we'll do this tonight, but, you know, eventually we want to do our own optimization passes and like move bytecode instructions around. And the problem is when you do that, you can't really refer to other instructions the way that we do right now, which is by index in the array. So if you try to jump to an index in the array, it's like, well, what if that guy moved, right? You have to go back and like dynamically patch everybody. So it's probably better to have a level of indirection or something of all the branch targets, which may be a good way of accelerating branching in compile time execution anyway, because the way that we do it right now, of course, when you want to jump to the next instruction, we just set your program counter there and it's all in one linear array. So that part's fast. That's going to get slower when we make this change because we're going to have to like search for that position. And so having extra information for branch targets that helps you search for them or just tells you exactly where they are is probably good. All right, hopefully the tea is good. Maybe you can use a chunking system that breaks up the array. No, because the whole thing that I just said about making it easier to patch in addresses and stuff requires that things don't move. That is just the requirement. That said, if we later go to a thing where there's a level of indirection anyway, then you could do them out of order probably. Like there's no, so you could just declare that that's the branch target. And then it fills itself in. I do kind of like that. The other nice thing is if the array is bucketed, I mean, it's just going to be necessary for it to be bucketed because, you know, again, we want to delete instructions in the optimizer, add instructions, all these things. You don't do that with a linear array. It's just not a thing. Will that be done at compile time? Yes. We're talking all about compile time right now only. Any other questions about this? Because I'm just going to start doing it. Because I really enjoy doing these things. Like, you know, when I start a project, it's like, I'm just going to do the simplest thing. I'm just going to add these into a linear array because there ain't no reason not to, right? And at some point, you start to see the reasons why you will need to have different storage. And I start to worry about it a little bit because, like, am I going to be able to engineer that without being slow like LLVM or whatever? And of course, the answer is yes. We'll never be as slow as LLVM. But am I going to be able to engineer that without being kind of slow? And just having done a little bit of it takes me closer to the solution. So it's nice. It feels good, right? It also means that I'm not being totally drowned by bugs, that we just doubled the beta size a few weeks ago, and we got some bugs. And there certainly are many more, but the rate at which people are hitting bugs is not an unbearable onslaught, which is great. Do I like LLVM? No. Does it do useful things for us? Yes. Out of curiosity, do you just call realloc or do you malloc and memcopy? Neither. We use our own fast allocator and just copy the whole array. So it's like malloc and memcopy, but without the malloc part. Will there be support for likely, unlikely branches? Maybe. We don't have that right now. My understanding is that languages that have tried that don't tend to beat the CPU's own heuristic estimation, and so it's kind of ignored. But I might not be up to date on that knowledge. All right, so I've got milk in the English breakfast, and then I'm going to use some of the other honey that came with the blue tea, because can't keep so many honeys forever. It's just going, I'm using the whole thing, I guess, going right in there. So I basically share Casey's view of compression-oriented programming. I wouldn't say it's the same thing. I would say, because I'm not sure that I think compression is the right thing exactly. But of course, compression is a nuanced idea. It doesn't, it obviously doesn't mean the smallest program text or whatever, right? I probably think about it a little bit differently from Casey, but it's broadly speaking a similar thing. It's just if I sit down to write code, I know I'm going to do it very differently. Both my resulting code will look very different from his resulting code, but even when I sit down and start, what I do is going to look pretty different from what he does. So it would be weird to claim that we do the same thing, right? If we sit down and start working and it's different things. Advent of Code 2020. I mean, I thought we had the advent of code in like 1950. All right. Was there even enough honey in the thing? Oh, I'm noticing the honey. Start with the simplest thing first, then branch out from there. Yeah, again, the way that I summarize my way of doing things is to get to a working program quickly, but not too quickly, because you need to not be building things that are going to be terrible in the long term, right? Which is what a lot of people do. It's okay to build things that are terrible in the short term as long as you have a story for how they're going to get swapped out. And you know that you have the discipline that you're actually going to do that. I am definitely drinking water with something. That is true. Okay. So I'm just going to start doing stuff. And, you know, if we don't even do it tonight, like whatever. All right. So right now, instructions is literally an array of these BCs, right? That's all they are. And instead, I'm not even going to make a separate thing. I've been wanting to put a bucket array data type into the compiler for a long time, but I'm not even going to bother to do that right now. I'm just going to have buckets. I'm just going to say, what do I say? I mean, I guess I'll just have the first bucket or whatever. And if there's any other stuff, bookkeeping that's necessary, we'll just put it here on the bytecode, right? Okay, the bytecode struct, I mean. So we're going to say well, instruction bucket first bucket equals null. All right. Instruction bucket is, well, we've got some const S32 instructions per bucket. It's just like maybe 16 right now. I don't even know. Because if we make this too big, we might waste memory and stuff, right? It's hard to guesstimate. So right now in the Sokoban game, we have 400,000. No, that's 40,000. I keep seeing the 400,000 bytecode instructions, right? And so that's about one per line of code, except that includes all the enums and things that don't actually have bytecode instructions associated with them. So well, and it's, 100,000 non-blank lines. And so it's about a 4-to-1 ratio right now. So one line of code being 4 instructions, probably like 6 or 7, maybe, for imperative code. Actually, that's not a very good, it's not a very good number. Let's try, see, I don't want to make it too big because I don't want big gaps, but whatever, 64. It's 64. All right, so we're just going to say BC instructions of instructions per bucket. Very simple. And there we go. That's all. Now the problem is, does BC like have a constructor? Yeah, that's annoying because I don't actually want to initialize. This is the problem in C++. When I make one of these buckets, I don't actually want this to be initialized. All right. But I also don't want to obfuscate it. I could like make an array of bytes and like whatever the fuck. No, but we're just going to have to like allocate this without. Yeah. All right. Okay. We're going to say make instruction bucket. Very simple, happy little trees, happy little accidents. Yeah. Because we don't want the instructions to be initialized. We are going to overwrite them later. Now we need some more stuff on here, right? Okay. So this has no constructor has been run. We need to initialize everything ourselves. This is error prone as we add things. In fact, I'm not even going to put this, like putting this equals null here implies that I think that that might do something. So beware. All right. Rust would not let us do this, by the way. Well, you'd have to say unsafe. You'd have to say we're leaving the land of memory safety and therefore failing in the poll. Okay. You know, it's either too hot in this room that I'm in or it's too cold. It's a damn shame. All right. So bucket next bucket is null. Bucket num instructions. Let's just say count. Count 0 buckets. 1 bucket. 2 buckets. Do I think the way I view programming that I said earlier is applicable to other parts of life? Maybe, but like, don't overgeneralize. Like program code, like large software projects are a certain kind of thing. And things that work for some kind of things are not the best tactic for other kind of things, right? That's all I would say. From Bitbucket, because I'm using buckets. I receive a cease and desist from Buckethead, the guitarist. I saw Buckethead in concert a long time ago. Okay. So we do this, and that's that. And when we make a bytecode, so the thing is we make empty, I need to think about all right. When we make a bytecode for a procedure, note that I'm not deleting this yet. I'm going to make it compile with all this stuff, and then we're even going to check it in. So I have that recorded, and then we'll start deleting things and changing them over, right? So the thing is, we make empty bytecodes sometimes for some reason. I don't necessarily want to allocate one of these, but when we add instructions, I don't want to have to like check if the pointer is null. I just want to have to check whether to cycle a new bucket because we add a lot of instructions. So I think when we make bytecode, add empty bytecode. Okay. Here we go. Here's what we're going to do. If it has a body, we will be allowed to add in. Oh, look, we have this up here. I actually looked at the code. And this is in like this interior block, but that's because this procedure used to be much bigger and more involved, and now it isn't. And that's kind of what caused me to look past this. Okay. See, we instructions per expression was 1.3. That was just my heuristic. I don't even know how based, but so I would pre-allocate the array so we don't copy it too many times, I guess. Huh. So actually, I mean, I'm sure we probably copied a fair bit, but no. Not as much as if we started with a tiny array. All right. If it has a body, we'll be allowed to add instructions. So lambda, or no, bytecode arrow first bucket. Make, did I call it make instruction bucket of interp? I think that's it. Else, well, this first bucket equals null. We do run constructors on this, so this should be fine. All right. Wasn't there a bucket head on Fat Albert? Yeah. I guess. Maybe Buckethead sent Buckethead a cease and desist. Make instruction bucket must return a value. How about if I return bucket? Why didn't the AI fill that in? All right. So now we're actually, in theory, allocating these for all the lambdas, but it doesn't frickin' matter because, oh, it does matter. Why am I crashing? What did I ever do to you? I almost want to say this is Visual Studio being flaky. Because this happens sometimes. I mean, maybe, actually, as I say that, I'm sure the probability of that is actually not that high. But let's try it. Let's just try a full rebuild. Because sometimes when you change structs by like adding fields, not everything gets recompiled. It's pretty rare these days, but it used to happen a lot more. I don't think so, though. I think I actually made a mistake that for some reason I didn't realize. Did I like typo anything? Let's see. Make instruction bucket. I mean, we didn't change anything. We just did the first bucket. All right, I'm going to run it. It's still going to crash. I kind of don't know what's going on. What did I do? That's so terrible. Seems like a thread safety thing or something. Let me check the get memory macro and make sure it does what I thought. That's the problem with it being a macro, is it's very easy for it to go awry. Wait, it get memory oh, what? How is that a type? Dude, C++ is bad. How could I do, oh, I'm doing size of on, all right. Macro for the win. So this is fine. So get memory and get memory new. I should call it no new, and then I would remember that it's a type. Kids, don't use macros. They're dangerous. All right, look. Ain't this what coding is all about? 90% wondering why it's not working. I mean, when you're a beginner, yes. I've heard people say that it's typical to spend 90% of your time debugging. That is not true, I think, for me anymore, although it might have been at some point in the past. You really want to get to a place where your debugging time is minimized. Which doesn't mean it's negligible. I mean, even today, I spend a substantial amount of time debugging. It's just, it's nowhere near 90%. I think it's more true if it's code you haven't written or a huge code base. Possibly, yeah. Like the less well you understand it, then yeah, the more likely you're going to spend more time debugging. That is for sure. Okay, so we've got buckets, and now I guess I'm going to check it in. Let's run it on the tests. So I'm going to check this in. Again, you know, I haven't been like typing furiously as fast as possible or anything. We're just having a chill stream where I talk over what I'm doing, so it's going a little slow. But, you know, the thing now is to switch over the old stuff, and it's mostly probably fine. There is, if I look for instructions, arrow instructions, which is the array, there's actually a scary amount of them, but a significant number of them are from code that's disabled. So all this is like if def out of the program right now, right? So this plus this is really not that bad. However, the tricky thing is some of this is like, this is indexing the array to set, right? This is branch patching like I was talking about. So we're going to have to make a temporary thing where we say get instruction index from, from the bytecode. So maybe I'll check this in. I'll do that. And that, like I did with the data segment pointer thing that you guys might have saw, somebody might have saw, which by the way is gone now. But it was just a temporary transitional thing where you make a function that just does the old thing. You put in the new data structure, you replace that old thing with something new that's like slow and crappy, right? And then you go address those sites, right? Okay. So this is step one. We're going to say started adding instruction bucket. It doesn't do anything yet. Okay, great. Are streams ever not chill? They are not chill sometimes. They're often chill, but they're sometimes not chill. Just had to turn the air conditioning off again because it's too chill. Tea with honey, man. It's so good. It's so good. It's a good liquid. Some of the gaming streams are less chill. That is true. That is a true statement. All right. So again, if I change the data structures over, see, this is an interesting lesson on how to keep as much continuity as you can through code without beating around the bush either, right? So my next step might be, well, delete that old instructions array and just switch everything over to instruction bucket. But we actually don't have to. So as soon as we do that, we have to get rid of everything that went arrow instructions and replace it with new code, like I said, right? But like I said, we can get rid of some of that right now. And actually, this is an interesting point. There's another point to be made here. Let's go look at one of these, right? So here's a thing where it's like, okay, we had a branch before. The index is branch PC. We just picked it up here, right? So this is actually really simple, where we just emit some instructions and then we do this, right? But we're doing it by referring immediately to the array, right? And the people who teach at mediocre computer schools and also who write mediocre how to program books would say, well, you shouldn't ever do that. You should have accessors and functions and setters and getters and all these things. And so you never have to explicitly refer to data structures, and then you wouldn't have this problem. And it's like, no, because I went 6 years with this and it was fine. You know what I mean? It's going to take a small amount of time to switch it over. And if you made me do getter setters for this whole thing, I wouldn't have understood what was going on. Debugging would have been much harder. It would have been much more heavyweight, taken longer to compile. It would have been unreadable. I would have been less happy the whole time, and I would be a worse programmer, right? And so, but that's essentially what we're going to do, is make an abstraction for this, but only because we're going to switch it over to something else now, right? It's like a very specific temporary tool. I'm going to do the following. I'm going to say, I'm going to say get instruction by index, right? And then say to change arrow index A equals here. Now, way later, so after I have the program working and switched over to this, then later on, maybe tonight, maybe a different day, I can get rid of this too, because you don't want to do this because this is going to be slow, because it's going to walk over. This is going to be like, I don't care how fast it is right now. It's just going to start at the first bucket. It's going to walk over all the buckets, right? But the whole part of the whole reason for the switchover is because memory won't move now as you add things to the array. So I could just use this pointer down here later and most of this code goes away. I don't quite want to do that yet, even though here I could just say BC, like BC and toChange are going to be the same thing. We could even assert that for a minute. But I kind of want to put this through some initial testing, right? Because it's going to be new. I might make a stupid mistake. So we want to actually use it for a bit too, to make sure that it's giving us the right answer. And then we can switch things over and then we can eventually delete it. Except in our first pass, even if we delete it for cases like this, we're still going to need it for like branching in the bytecode runner. Anyway. Getters and setters can go die in a fire. I know. I'm so glad that I had enough programming experience as a kid that when I started being exposed to that getter setter stuff, I just knew I had like an aesthetic rejection, an internal aesthetic rejection of that stuff, because I just knew how nice and fun programming was. And I knew that it didn't look like that, right? I knew that programming didn't look like putting getters and setters everywhere. Thankfully, that wasn't my first computer class. Oh my God. Now I need to find the tea strainer. I don't know where I put it. We're going to run it back. We've got more milk. Oh! The milk was a little more full than I thought. That was great. Fortunately, only 97%, or fortunately 97% of the milk landed in the mug anyway, and only 3% of it, and more like 7%, landed on the mouse pad and will make my mouse pad smell like milk infinity into the future. Okay. Since we used our new honey, we're back to the honey bear. And honey bear doesn't flow very smoothly. Come on, honey bear. I'm going to leave honey bear upside down for a second. No, honey bear. All right. Microwave it? No. No, it's a plastic honey bear. Okay, so we're doing this, and I'm just going to do, even though, like I said, I could just do this, I'm just not going to do it yet. Okay, and then this goes away, right? And then this flag is branch target. Right now, that probably does get instruction by index. Let me see. Yeah, we're gonna do that here too. So this is again going to be redundant work, significantly so, and slow because it's going down a linked list of buckets. I don't care. We're going to take these out. But right now I'm constraining the problem to just substituting this one thing, right? We're going to do the rest of it later. We just set the flags on the instruction. And this as well is going to have to change as well. But we'll do that in a bit. Okay. Instructions. Note byte code location. We're going to leave the counts for a second. We're just going to do this in a pass. This is the program counter. Let's not actually change that one yet, because we're not gonna want this one to be get instruction by index in the end anyway. We're gonna want to change the loop. Oh wait, no. This is get instruction by, oh, never mind. I thought this was a different loop. Oh, this sucks, dude. Okay. This is going to be a little more work. When we make a patch, actually, no, we just save it. We save a pointer to the bytecode. That's fine. In the patch. So we just do that for now. Okay. Count, add. So this is the function that like literally just adds the instructions all the time. We're not going to change this yet, because this is the thing that's actually making things work for now. Dude, the honey bear is not cooperating. The honey... How long have I been streaming on Twitch for? 1 hour and 9 minutes. What arch am I targeting? It doesn't matter. Doesn't matter. We're not working on assembly language today. We do have honey in jars sometimes, but sometimes honey comes in bears. Don't you know? Bears like honey so much that sometimes they eat all the honey and then you have to catch the bear to get the honey. Get one of those sticks with the weird ball on top. Yeah, those are good, actually. Those are good. Put it in hot water. Maybe. I mean, I think I've got enough now. But yes, the hot water is the play for the future. Honey bear is uncooperative. Honey bear wants all the honey for honey bear's self. All right, now the tea's cold, probably. Spent all the time getting the honey out of the honey bear. Honey that comes in bears is not real honey. It says it's wildflowers. Okay. So this we're not going to change yet. Oh, dude, we already have frickin' get instruction. Okay. I want to get away from all these methods though. So we're actually going to, as part of our annoyance, we're going to get rid of this. There's no reason for that to be a frickin' method. Oh, it doesn't. Interesting. So we do that a lot. Okay. So we're just going to turn that into get instruction by index of current byte code, comma. Oh, but again, this is mostly being used for the patching again anyway. It's kind of interesting. All right, so that's gone. All right. Let's just make sure I didn't break anything too badly there. Get instruction by index identifier not found. I never identified it. All right. Let's put that here. Inline. Get, inline. BC. Get instruction by index. Bytecode, index, or I don't know, right? Bucket equals bytecode first bucket while bucket, and then we'll return null, and that probably will crash us. So while bucket equals bucket arrow next bucket, but before that we say if index, oh actually, so we're going to actually subtract from index as we go through this loop. So we're going to say if index is greater than or equal to bucket arrow count, we continue. Otherwise, assert index is greater than or equal to 0, because why not? And then, so they are going to be stored contiguously in this array from 0 to count, in this little nugget array. For now, we might change that constraint far in the future, but for now it is. So we're going to say return and bucket instructions sub index. Okay, so for here, index minus equals bucket arrow count, right? Because we're counting down. Done. Now I'm too hot. Well, that all compiled. Let's make sure we didn't break anything. Oh, we did break something. Really? Probably the get by index, right? Wait. Oh. Oh, guys, I typed in the new code. See, I'm a dummy. I got ahead of myself. I typed in the new code for later, but this is not my beautiful house. That's for later. For now, we just say, the whole point of this was that, right? When I said, talked about getter, setter and stuff. All right. All right, I'll make it the right type. So we didn't find the instruction because these buckets are all empty right now, everybody. They got nothing in them. I hate to tell you this. They got nothing. The buckets have holes in the bottom. All right. So again, that's what we're not changing. Here is a thing. Let me just copy that from before. Current byte code and branch out PC, and then to change index A equals here. Flag is branch target. Yeah, all of this stuff is going to get cleaned up. Don't you worry about that. Same thing here. It's called branch PC. Same thing here. That's branch out PC, okay. Could easily make a clerical mistake doing this. This is branch PC. Whoops. All right. We have a lot of instructions.count, but we will do that in the second pass. Okay, this is loop exit patch PC. We do this. B loop skip. Oh, this is our thing from just this morning. We just did this morning. Byte codes match. Oh, wow. We actually do that? Lol. We really should probably use a hash or something. Anyway. We'll rewrite that later, because that's again going to be a loop over buckets with a second loop over buckets written in a slightly different way. It's mildly annoying, but it's okay. Poke completed address uses. See, I could make a mistake there, like leaving the current byte code or whatever, except I think that's what it was. All right. This is old run bytecode inliner. That's defined out. So we're actually going to put all this code somewhere else. Don't I have an old folder? No. Old inliner code that is disabled and should be replaced by something much simpler. Bam. Okay. So, well, we got a shrinkage in line of code size there. Okay. So, oh, that's the end of the file. Okay. So, really, we have get instruction by index. That's our thing there that is commented out. That's the thing that makes instructions. Bytecodes match, which I said we would rewrite later. Although we probably do want to do the temporary get instruction by index there. So let's do that. And that'll be the end of this file. Whoops. Because when we switch over the data structure, we're not going to have to write this at the same time, right? We want to give ourselves some slack. All right. What? All right, I could easily have screwed up any of those. So we'll see if it blends. It's going okay so far. So I think there were a few more. We got to look back at the find results. There were a few more in these other files, right? So here, oh, run loop. Okay. We're not going to change that. No, you know what? We will. Screw it. Yes, we will do it. It doesn't matter. See how little I care? We're going to be slow. It's like I'm passive aggressively avoiding doing this because I know it's going to be slow, but we're just going to do it. And then we're going to make it not slow. This again will instead just pass in the pointer from the outside, and the outside will be a loop that works differently, right? Lol. Okay, this is a little bit different. Dwarf debug info, line 716. We're going to say all right, and then we'll say, yeah. First is stack trace node equals this. That's just very silly. We're going to want to take that out in the end anyway, but first is stack trace node. All right. LVM converter, last file. Emit this. Okay, yeah, that's going to be sucky. Slow. It's fine, though. It's fine. We're gonna... fix it later. We're gonna fix it later. We're gonna fix it later. This is such a silly loop right here. Oh my God. Okay. And then this is even worse. Oh my God. Oh my goodness. Oh my golly goodness. All right. Get instruction by index can get wrecked. Get wrecked. We'll fix this later, the source of every object later. No. Okay, this is what I'm trying to teach people. No. It is good to we'll fix this later if you actually fix it later. The difference between good and bad programming is not that good programming is preemptively doing everything perfectly, because you'll never get anything done that way. The difference between bad programming and good programming is actually fixing the things that need to be made better. That is the difference. A lot of these really misguided, programming philosophies that people try to teach you and sell you books about are all about doing tons more work up front to prevent problems. And in a large percentage of cases, the cure is worse than the disease. It's just not. Just beware. Beware. Okay. So this is great. Now what? Well, we got rid of all the subscripting except a couple that are mandatory for the functionality we're doing. And now we will go to, we have instructions.count. We noticed a bunch of those. And what we're actually going to do is put a num instructions on the main. Remember when I said, hey, any additional accounting info we could put here, right? We're going to put a num instructions on the bytecode right here, right by the first bucket. All right. And every time we add an instruction, we'll increment that. Why? Because we don't want to have to walk over the buckets to know how many frickin' instructions there are. Because we probably want to know that a fair amount, although we may need to know it less than it seems, because a certain number of these things are like looping over the instructions, and that loop is going to be different later. But, for now, again, we're transitioning. So the thing that adds instructions is right here, and we're just going to say num instructions plus plus. It's C++, so we're num instructions plus plus. So now, well, I'm just going to manually replace these. I could do a global automatic replace, but again, it takes a little bit longer, but I want to look at each of these. All right. And I actually don't know if there's an interactive query replace. In Emacs there is, but it only really does. Let's do it, because there's only a few files. So we're going to replace arrow instructions.count with arrow num instructions, and basically it should always be the same. Like it should always be legal, right? Except here, this is old code. Like, again, they're both the same, but like, yeah, that's fine. Start lexical block. Yep. Emit block. Emit statement. Yeah, I guess so. That's in a comment. That's going to go away anyway. Okay. So that's everything in that file. And we have bytecode runner. Empty bytecode. Program counter. That's probably going to change anyway. That's definitely going to change. All right. And then dwarf debug. Oh, yeah, that's the thing we were just at. I remember that. And LVM. Oh, God. Oh, this makes me cry. I'm going to have to rewrite that. I'm so going to have to rewrite that. Okay. Yeah. Okay. This will probably change. This is definitely going to change. Yeah. So a lot of what we're doing is interim, but there's a tremendous value on a program this complicated to keeping it working from step to step. In fact, assuming it still works, I'm just going to check it in again. Top loading is the enemy of productivity. That is correct. Because again, as I always say, or always since I figured out how to say it, when you start doing something complicated that you haven't done a million times before, you're not an expert at doing that thing. You're a novice at doing that thing. And so top loading all the work, trying to do all this preemptive engineering to figure out the best way to do it is a bad idea because you're a novice. Your engineering is going to be mediocre. Your engineering decisions are going to be mediocre, right? Your job is to get experience in that subfield of particular problem solving that this program is about. And then you can make better decisions once you have that experience, all right? And so the goal of this style of programming is to get you into that zone where you're getting the experience and understanding what the program really needs to be, as opposed to what novice you at the beginning thought it maybe should have been. You'll waste a tremendous amount of time making bad engineering decisions if you do it that way. Do I actually enjoy writing C++? I mean, now I kind of do because I know I'm getting off it, right? The whole reason I started this programming language is because I was depressed, because C++ was making me depressed. And that's not, I'm not making that up. I'm 100% serious about that. That is how it was. All right. Whoops. I didn't mean to do that, but I don't think anyone else is modifying anything, so it's fine. This is just an auto build from the server. Okay. Commit. Further work towards replacing the way bytecode instructions are stored. Okay. I actually wonder if we've taken a noticeable speed hit yet. I mean, the speeds is kind of random. Yeah, I mean, I want to say we're consistently like less than 5% slower, but enough that I see it in the numbers. I mean, but who knows? The PC could have decided to do something different. But again, that's expected. That is part of the process that we are doing right now. Okay, now what do? First, I turn the air conditioning back on because I'm too hot again. Okay. What am I doing? So I just committed. I'm not afraid of commitment. And, well, so we've hit sort of probably what are the two major sources of using that instructions array directly, but there might be some more. Let's just see who refers to. Oh, look, see, we've got it down to quite a small number of things. So again, these are the stuff from the header file. That is fine. This is the thing that adds instructions. Again, we're going to replace that. You know what we could do if we're fancy? I was almost going to say we could actually maintain both in parallel, but that's actually not true. That would be more annoying than it's worth, because we go back and modify them, and we'd have to like modify them both, and that would be stupid. So we're not going to do that, although that would be funny. So this is all just, you know, that part. This is literally the only one that I missed for some reason. Is it called get instruction by index? I used autocomplete, guys and girl. How many people are watching? 297 viewers. So at our approximate statistics that we always get told of like 99% male, well, you know, that's how it comes out. Says 310 for you. Well, you know, we don't live in a consistent reality. All right. I mean, let's just make sure that that works. And then we're going to throw this switch. We're going to throw the switch. I just like hitting the compile button. It's so fun. I'm just compiling the game so many times. Okay, so here's where it actually gets a little bit annoying, but again, it shouldn't get that annoying. It shouldn't be very scary. All right. Step one, when you lock the target, you do that, you do that, you do that. All right. So now, oops, arrow instruct. What was that up there? We don't need that. This is some really old comment. Okay. That's fine, because that's from the bucket. Okay, there, boom. And then where's the instruction? That shouldn't be a method either, honestly. Like, I got to get rid of the methods. Okay. I don't know why we even have two overloads for this. Like, I'm sure, oh geez. Case sensitive. Like that's just the call to the other one. Yeah, like literally I broke it into two things because maybe we used to call the other one, but it's really just one thing now. So combine these, please. All right, so why is this by value? Why did I do this way? Oh no, that's an enum. That's an enum. This is so weird, guys. Okay, this is... I was on crack. I admit it. Okay. So the invariant is on entry, there's always at least one empty slot in the current bucket. Once we put an instruction there, though, it might be full. So we may need to add another empty bucket. Okay, so we're going to need another bucket pointer, which is fine. See, this is annoying. I want to inline this. Like, we're making a thing by value and then adding it to an array, which is an extra copy, which again, like, blah. We should just get the pointer and fill in the pointer. It's all fine. It's all fine. It's all fine. Okay. It's all, we're going to take care of it. Don't you worry. We're going to take care of it. No check-in, don't copy. Okay. So instead of doing this stuff, which we're going to remove, oh, there's next instruction. We want to keep that. We're just going to say dest, right? And then return dest. Okay. What is dest? Dest equals, we're going to say bucket is bytecode last bucket, right? Dest equals bucket arrow. So what did we say? Bucket arrow instructions sub bucket arrow count. And I'm just going to put this... I don't like doing the C++ thing of putting that in there. It's no, we don't do that where I come from very much. Okay. So then, because we're copying right now, we say star dest equals BC, just copying the value in, right? Okay, that's fine. Let's keep going. I'm sure there's some other references to that array, and we're just going to let the compiler tell us which ones those are. Hey, guess what? It's getting too cold in here again. 409. Wait, what? Oh, I didn't make last bucket. If you want to succeed in the games industry. Wait, not there. No, it's here. It's there. All right. And so when we do that, right? All right. So now we haven't done the following thing. Like we said, when we do this instruction paren, we need to maybe make a bucket. If bucket arrow count is equal to instructions per bucket, then, well, we make a new bucket, right? And then bucket arrow next bucket is new bucket, and then byte code last bucket is new bucket. Sure, I'm glad I went to 5 years of computer school to learn how to do that. All right. I actually probably learned that in high school. We had a Pascal class where we did some basic data structure stuff. It's just that class wasn't like the examples that we would do this for were just kind of silly. I don't know. It never stuck with me very much that it was real programming. All right. Des is undeclared identifier. Oh, auto. We didn't go to the auto zone. Go to the auto zone. Instructions. Okay, that's a remaining one we haven't replaced. Oh, yeah, we don't need that. All right, so now we find out how bad did I screw up. $100,000 line video game with bytecode stored a different way. Everybody. So that's, you know, that's how I do things. I mean, we're not done yet. We're not done yet. But because we got to switch over those things to not be slow. But that's how I do relatively scary changes. We had a working game the whole time, except for like minor hiccups. And one of the core data structures is totally different now, right? And we didn't have to use getter setters on it for 6 years of code bloat. And yeah, I mean, let's make sure all the tests run before I get too far ahead of myself. But, you know, I mean, to be fair, it's a relatively easy, it's, you know, it wasn't rocket science, the switchover that we did, but there's this, you know, there's this practicality about programs that it becomes hard to do things sometimes because everything is affected by the thing that you're doing and like it's scary and whatever, right? So you just want to not be scared and you plow ahead and do it. And there you go. So I'm going to, you know, assuming that this passes, which it probably will, we'll check that in. And then our job is just to now get rid of the thorn that removed the thorn, right? So the thorn was that we were depending on this array everywhere. And then the thorn that removed the thorn was, whatchamacallit, get instruction by index, wherever that lived in bytecode.h, right? So now our problem is just this. But that's honestly a kind of a tractable problem that's addressable on a case-by-case basis, right? We don't want to call this at all if we can help it, ever, because it's iterating over these buckets to find the thing. Okay. Bytecode instructions are now stored in a bucketed fashion, in a bucket head fashion. Are there? Oh, I have a no check-in, guys. What did I do? Must have been important, right? Combine the, oh. You know what? I think we're going to check in and then combine them. Wait. Now I'm paranoid. What did I do? Okay. Because I feel that's success right there. And then the rest of this is optimization. And also I didn't want to delete that comment. Okay. We're going to do this next. Remind me if I forget, because I'm going to heat up some more tea. Are there any questions about what we're doing so far? So again, we're not totally done with the switchover. Our program functions now, but we want to get rid of this thing that is stupid, really, and is eating, you know, probably a few % of compile time right now. And we don't want that. Famous last words of mine, diffuse specialist. Well, like I said, different kinds of work are different, and different techniques are appropriate for different kinds of work. Since you've made a bunch of changes to your code, when is enough change that you would then update your tests? No, this code, you're thinking about unit tests. I don't unit test. I'm not a unit tester. Our tests don't change. Our tests are tests of the compiler. They are tests that the compiler functions correctly, right? That's the thing. If you spent all this effort making all these little unit tests about how bytecode instructions are stored and where they live relative to each other, then you'd have to delete those and make new ones. That's not what these tests are. These tests are like end user code that uses our programming language. Okay, it's a different thing. What exactly is a bucket? It's just a smaller array. It's just the following thing. It's just this. So instead of, like, if you have a function that ends up having 1,000 bytecode instructions, which honestly is not really that many. We certainly have functions with more than that, with a lot more than that. You know, before we were storing them in a contiguous array, which again is annoying to maintain once you start doing operations where you move instructions around, right? The pointers aren't stable and all this stuff. So you don't really want that. So we've just transitioned toward a different thing. And we may change this to something else later, right? This just stores 64 at a time in one contiguous chunk of memory, and then it's a linked list, right? Pointer, 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 pointer. It's all good. We may change our mind later about what this is, but we get some properties that we will likely want to keep, like pointer stability to the things. And, you know, we're going to start building up from there. Is this intermediate stage or very back end? I mean, this is this is what the LLVM people call the intermediate representation, right? It's our equivalent of that. Can you see an example of how the bytecode looks like? Well, there isn't a written representation. What happens is we go like this. See this macro instruction that calls that instruction function that we were just doing? We do things like this. We say, let me find a different one that's not, you know, we say, make this instruction, make that instruction, make that instruction, you know, make that instruction. So it's not a written form. It's calling a function form to add these things. 64 bytes per bucket. No, 64 instructions per bucket. Yeah. And that's again, you know, that might not be the right number. That's easily tweakable implementation detail. Don't we have an easy way to turn arrays into buckets? I mean, I took that out because it wasn't that good. But you could probably do equivalent things at user level, but this is C++, and so we don't have any of that. How many bytecode instructions are there? Well, I'll show you what they are right now. They are this enum here, which is, you know, a couple pages. I don't know. It goes from line 33 to 144, but there's some blank lines, so about 100 right now. Something like that. Compiler only uses those instructions? Yes. I mean, as its intermediate representation. How many will there be? I don't know, because we want to support more intrinsics and stuff. I don't know if having one instruction per intrinsic is really the right way to do it. That said, we probably won't have as many intrinsics as a lot of things because we probably want to do inline assembly, and maybe we'll do intrinsics that way. It's hard to predict. So the buckets have nothing to do with bucket sort? Not really. I mean, no. Did I consider having an array of bucket pointers instead of a linked list? Sure, but that doesn't totally matter right now. We could do that. The thing is, it doesn't help you that much. So you might think, hey, if you've got 64 instructions per bucket, then if you have an array of pointers, you can like go mod 64, which is cheap because it's a power of 2, and that gives you the bucket you can go divided by 64 to get the bucket index and mod 64, but that actually doesn't help once you start removing things from buckets and having half empty buckets and stuff, which we will when we're manipulating instructions and moving them around, all right? So that kind of thing is like maybe getting prematurely excited about something that's not actually going to work. Yeah, we both translate it directly to machine code or translate it to LLVM, depending on what we want to do. We are back on the Bengal spice train, everybody. Okay, so let's start looking at some of these things. So just like before, I did a search and I was like, I've got to get rid of all these explicit references to the instructions array. Now, wait, did I check it in? I think I did, right? Yeah, okay. So now we want to get rid of get instruction by index. Whoops, except don't typo it. If you want to succeed in the games industry, don't typo the thing that you're searching for. See, we have, again, it looks like a bunch, but it's not too bad. A lot of these are by bulk. They're those instruction changing things. Oh, you know what I should do? I should run it in debug mode at least once to make sure that those asserts don't go off. They won't, but let's just build the game in debug. Because remember, for example, I asserted, oh, it did. Okay, that assertion is actually, Good thing I did that. The assertion might be wrong. I'm not sure yet. Let's find out. Let's find out. Because the code seems to be successful. So what's BC, right? To change. Did I copy the assertion incorrectly? Branch out PC. Oh, okay. No, see, this is branch PC. All right. Yes. Okay. This is just a wrong assertion because I was looking up here and like, oh, the BC, but it's getting reassigned down here, right? So it's fine. The code is actually doing the right thing because we're not using BC, but the assertion is wrong. So let's just go change it now because it's time to start getting rid of these. Okay. Like if we had these be different names, then this would be a correct assertion, right? But we overwrote it twice. Instead of doing this, I'm going to say branch BC there, right? Let's do this. So that's what we meant to assert. I don't know if we have more of those asserts. Let's find out. Okay, well, they're the same everywhere. So now that just means I don't have to call get instruction by index, right? I could say instead of toChange, which we don't need because these are equal, right? Since branch BC is equal to toChange, I don't need toChange, which gets rid of this, which is great because I don't want that, right? toChange is gone. And this becomes branch BC, right? And then this is small enough that I don't need an intermediate variable for this, right? So this becomes just that, okay? Now, we might as well do one of these as well. So this, remember, let's go look at that function. It also looks up things in an array or using the function that we want to get rid of, get instruction by index. But we can make a version of it again and delete the old one. So what I'm going to do is make an overload of this that says why did you reformat? I literally just pasted the thing. So we're going to go just pass it in, right? If you pass it in, then we're good. And honestly, since we're going to touch this memory anyway, let's do this. We're going to go assert index is less than bytecode num instructions. All right. And here we're just going to say if toChange. So if you pass null, you're saying the next instruction that doesn't exist yet is a branch target, which we do sometimes. That's what this is for. So that's fine. So in addition to switching things from this to whatever, we're going to be switching from this one to this one. All right. Oh, and here, whoops. Oh, geez. I just Control-Z'd the wrong thing. So here was get, oh, note bytecode location. Oh, right. Okay, we'll go ahead and keep that. We'll go ahead and keep that. We might want to clean these up later because maybe these will combine. But this is going to be the basic pattern now as opposed to the longer thing that we expanded into, right? So here's another one. So this is branch out PC, which is here. So we're going to do that. And actually, we don't need, okay, hold on. We don't really need this anymore, I don't think. Branch out PC. Dunzo, yeah. So actually, that's probably true for the previous one as well. We'll go back in a second. So we don't need this. We say branch out BC, and then we're going to pass it here. All right. What was the previous one? This one. So branch BC, branch PC is not used. Yeah, great. Great. Is almost like it makes sense. Okay. So we just keep doing that for a bit. Okay, same thing. Branch BC. PC's gone. We're going to do this. Probably this is gone. So I think we're going to have two of these. Yep. So branch BC, right? Branch BC. Wait. See, I almost deleted this line. It's very easy to make a mistake like that. Yeah. So again, branch out BC. I should have better names for these that are not as similar to each other, but I don't right now. So because I made like overzealous deletions and stuff, I think it's going to be a good idea before checking in just to look it over. After running, we'll run the tests, and then once they pass, we'll just look it over to make sure. Okay, so here's another one, right? Branch BC, right? All right. This one is one of those funny ones where, you know, next instruction. So we pass a null and that'll switch it to the new overload of the thing. Done with everything target. I think that's the same. I should be searching for the other thing. This thing, get instruction by index. Previous case, go to, okay, that's a we'll do that one later. That's like a less trivial one. I just want to keep doing the ones that are just right in the function body like this. So here, flag is branch target. Instead, we can say, actually, I mean, I just put BC if here. You know what I'm thinking right now? I'm thinking we changed a bunch of these and we want to compartmentalize. Oh, see? We want to compartmentalize our changes so that if something goes wrong, for example, if I run the tests now and they don't work, then we kind of want a smaller field of things to search through to figure out the problem. So, oh, for example, hold on. Wait, what? 959? Oh, it's here. Oh God, guys, I'm passing the wrong thing. I'm passing the wrong thing. This is one of the null cases. Okay, I have to re-audit all of these. Ay, ay, ay. This is one of those cases where we're saying, no, dude, it's the next instruction. In fact, probably all of these want next instruction. right? Because what we're doing is, I should actually make it a separate thing. Flag next instruction. I don't know why I did this way, honestly. Because we don't need this index even. Yeah, you know what? You know what? Isn't that simpler, right? And then we can do this like I was saying. I'm making a lot of changes here. We're just riffing. We're just doing some stuff. Like, yeah, all of these actually want this. I was passing the branch source, which we might want to do later, honestly, but that is not the intent of this function at this current time. Someone's sure zooming around outside. So I'm pretty sure this is the intent of these things. Yeah, okay. Okay, so now we're getting into these other things. Okay, so flag next instruction as branch target. See, this one is only for backward branches. Or, I mean, I guess it could be a thing where we lay out branches and then patch them up at the end. But often, like, you're writing some stuff and you don't know what's going to come after. And so, yeah, we want this. This is just clearer. I don't know why. I don't know why I didn't just do it this way the whole time. Because I'm dumb and I'm getting more experience at this. Like, isn't that better? Isn't that better? Come on. Come on, bro. All right. Now, how bad did I screw all that up? Not too bad. Not too bad. Not too bad. Okay. Let's run it on the tests. It seems like the tests will probably pass, but I'm not going to bother running LLVM tests because everything we've been doing is prior to the backends so far, and so it's just going to be the same. You think what makes this stream good is that I'm not wrestling with the computer to get the idea on paper. All the typing and function calling is just on the back burner of his mind. You know, I don't watch enough other programming streams to know what they look like. Like, is it a lot of people thinking about what they're going to do or something? Like, what does the typical day of a Twitch programming streamer look like? Apart from, you know, learning JavaScript frameworks. Is there any OOP stuff? No, there isn't. There is not. No. 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 So I'm just going to continue what I'm doing. Let's, for morale purposes, just search for this and note that we don't have as much more now. Look, this is all we have to do. Oh, actually, wait, that's flag as branch target. Never mind. We want to search for get instruction by index. It's probably more. Yeah, but it's, you know, it's less, and it's less than it started, and it's not infeasible, right? After all, we added all these at the start of this stream, and if we added them, we could take them away. Is a separate bytecode straight to machine code path going to be for faster debug compiles? Yeah, it already is for that. Most program streams is a ton of distracting things for the follows. Yeah, I refuse to. So, you know, early in the days of Twitch, they had official guidelines where they encouraged streamers to do that. And they may still say that in the official guidelines under the guise that, like, the viewers want personalized attention and stuff. And that's true, but nobody wants to sit there and watch you say, thanks, Foozle133 for the 10 bits for like an hour, right? It's boring. I just turn off streamers that do a lot of that. The way that you interact with the chat correctly is like they could ask questions and you answer questions, and the content of those questions is interesting for other people, right? You want to be saying things that's interesting for other people. That is my theory. Of course, I also just sit here and stare at the screen a lot, but that is what it is. Book recommendations on writing compilers. I don't know. I bought a bunch of compiler books like a couple years ago just to see, and they're all just kind of meh, in my opinion. I mean, for beginners, they can help give you context, but none of them actually tell you really how to do it the good way. Or a good way. There are multiple good ways. All right. So let's go back to the grind. Get instruction. I can't believe we did that many. Okay, this is flag as branch target. This is legacy. It's going to go away. All right, this one. We'll wait till later. Not that easy. I mean, it's fine, but we'll wait till later. Here, this is more of the kind of thing that we've been doing. So loop exit patch and loop skip. That was the one that we did this morning, right? Wasn't it this morning that we fixed the for loop? Okay. Loop exit patch. Okay. BC loop exit patch BC. BC loop skip. And BC we might be using, no. Okay, these probably do need to be integers because these are targets. Right now, branch sources need to be bytecode instructions and branch targets need to be integers. Okay. So loop exit patch BC, loop exit patch BC. Let's just do this. And then loop skip was the other one. Loop skip patch BC. All right. Like, it's just simpler, dude. Just simpler. All right. Now what? I mean, we could just make sure that that works because that affects all the numeric for loops, which could be substantial. Undeclared? Really? Oh, I didn't change the P to a B because I'm a dummy. D for dummy. Okay. 63. What? Oh, no. What? Skip patch BC. Loop, skip patch BC. What is your major malfunction? Look. I said look. Somebody in chat caught it. How many files does the compiler consist of? Well, that many. It doesn't summarize the number of files, but it's a few screens. But I also don't go in for this thing that a lot of quote modern unquote programmers do, where like every file is like 200 lines. I think it makes programs really hard to understand. So, you know, we've got 8,000 line files, blah, 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 right? So it's all good. I probably should try to remove some of these littler files that have less of a point. Thoughts on Ruby on Rails? No. 200 line files is a thing? Yeah. Oh, totally. You can search on the web, and the same people who say functions shouldn't be more than 10 lines say like files shouldn't be more than whatever. Dude, if I had to limit myself to 10-line functions, I don't know where this compiler would be functionality-wise, but a fraction of what it currently is. Okay. So, wait. So we built, did we? Okay, look. Look, I did it wrong, guys. That's good to know. Loop, skip, patch BC, assert loop exit patch BC. Did I like say auto or something? Loop exit. I did, because again I was doing the thing that, remember how before it was called BC because it was reusing the name, and so I said auto whatever BC in the earlier cases. You don't want to do that here because we're passing the variable out from the thing. That wasn't the only... I did it in the other one too, didn't I? No. Wait. It's loop skip. I did it in the other one, right? Loop skip. No. Loop exit. I want to see both of them. I'm not seeing both of them. Loop exit. Loop exit. Wait. I don't get it, guys. Let's see what's going on. I took a look. I didn't see the problem. Set comment is defined to not do anything in release builds, which is why that didn't error sooner. What did I do wrong? How is that okay? That's a breakpoint on a non-code line, which means we had the weird Visual Studio or Emacs bug where there's a control M in the file. Right there. See that control M? It confuses Visual Studio about how many lines there are. You have to terminate those with extreme prejudice. All right. Took me a while to figure that out, dude. It's so frustrating. Did we not have a problem? We compiled. Did I not compile this correctly? What's going on? Did I not recompile the compiler? Am I not going to succeed in the game industry because I didn't recompile the compiler? I didn't, because the Control M was only in parser, but we were editing this. Guys, I did not recompile the wait, I did. We have a thing that works in debug build, but not in release build. Hold on. Hold on. What happened to the reg export issue? That is fixed. It is working great. I have not shipped to the beta testers one of the bug fixes that was involved. The first one, the Boolean cast to integer fix, that should ship tonight after the stream or in the wee hours of the morning. Okay, that, do you see what I'm saying about somehow you change header files and Visual Studio doesn't recompile it correctly and then it looks like your bug? That is very likely exactly what that was, because I did a full rebuild and now we work. Okay? And people ask me, what do you mean you're not supporting incremental rebuilds? They're great. They make your compile go faster. And I'm like, no, they're very complicated and they add all sorts of bugs and they've never worked correctly for me. And it's just, it's very aggravating when you get hit by these. And some of them are so bad. Like, I think still, last I checked, if you modify a file in the middle of a compile, like while Visual Studio is compiling, it just marks, like, it marks the end of compilation as, okay, everything's up to date, even though it may have already read the file that you're modifying. I do that all the time because compiles are slow. Like, it's just so bad. We need to, like, just, there's no excuse for these things now. It's the year 2021. Like, we need to start solving some problems and making computers not ass. All right. That's all I'm saying. Let's run it some more just to prove it's not like a spurious problem. Like, look. Okay, no, not that bad. I got to rant, and I like ranting, so it gave me an excuse to rant. Thank you, Microsoft. Thank you, Microsoft. Okay, I sort of feel like I said, we kind of want to break these into tranches so that, well, okay, let's run the tests. And when they pass, we'll check in again to like minimize how many question marks are going on at once, right? Okay, so we're going to search again, get instruction by index. We didn't really do that many that time. That was just the loop. But because we had this weird compile error, which I believe is Visual Studio mismanaging, you know, dependencies, quote, dependencies, unquote, but may not be. It may be my fault. I may have introduced a bug, but I don't think so. Sure doesn't look like it. So we're just going to checkpoint here, and I'm just going to say, you know, what did I change in parser? Oh, white space. White space, baby. Is the word white space going to be considered hostile soon? Anyway, modify numerically ranged for loops. Okay. All right. Next, get, oh, we're in the wrong file. Get instruction by index. Go to source pause. That's up here, right? auto go to source BC. So go to source pause. I like this better. This is just nicer. It was always just a little confusing having to write this kind of code. There we go. Okay, get instruction by index. Go to first non-default case source. Go to first. Yeah, okay. First non-default case BC. That was long. I could have just pasted that. So this is significant because if I screw this up, we're messed. I don't need this assert. I could change this assert, but like oh, yeah, okay, no, I should, because there's just this if statement here leading to a little bit of, yeah, all right. So that's switch statements. Get instruction by index. Previous non-default, oh yeah, switch statements. We're going to get that later. It's just, we do the same thing that we've been doing, but this is stored on a data structure instead of in the function because lots of stuff can happen. So we'll do that in another pass. This one, go to source if part pause. Right? So this is we have an else part as well, clearly. That is assigned conditionally. So we're going to make that null. Make that a BC, else part. This is, we do this and BC. Okay. I could do these flag as branch targets right now, but to minimize potential for confusion, I'm going to do that later. So then where's the if part one? If part, yes. These are not very illuminating names, I have to say. Let's just do this. Flag next instruction as branch target. We're just going to do it. It's just nice. And then we do this. It's just fewer variables flying around, you know, okay. Great. Great. It's so great. We're going to get tired of winning. BC left. Go to false, left. Go to false. See, okay, like how clean is that, guys? Oh, wow. And then honestly, we know what the next instruction is. So this is a case where we could flag manually, but like, you know, maybe we just do this all the time. I don't know. I don't know. Here's another one. BC done. Go to done pause. Go to done pause. Bam. How very nice. Okay, 3262, I goofed. Else part pause? Didn't I delete that? Else part pause. That's a BC. That's a BC breaker 119er. We better run this. Any opinion or insight on Apple's M1 processor? I think the M2 processor will be even better. You know what? No, I'm tired of people asking me this question. Like, okay, I realize that this is the new thing in the news, the Apple M1 processor. Oh, it's faster and all this. But guys, it doesn't matter. It doesn't matter how fast CPUs are for almost anything in your life, because all that will happen is the same programmers who are making CPUs orders of magnitude slower at doing actual computation than they should be are just going to make them even slower. That is all that happens. And no, they're not trading that off for productivity because, again, they're not productive. So why do you care that a new faster CPU is coming out? Your computer can be 100 times faster than it is with slightly different software. All right, at least 100 times. Probably a lot more than that. Oh no, the M1 is like 40% faster. You could be 100 times faster. 100. That is what I think about Apple's M1 processor. Computers are so fast, you have no idea. Most professional programmers have no idea. Most professional programmers have no idea how fast computers are. They're crazy. They're insane supercomputers. Who cares if M1 is twice as fast? You could be 100 times faster starting today, starting right now. Right now, right this second. I guess it's becoming a ranty night, isn't it? Isn't it? Okay. Where do you download the fast software? Unfortunately, you have to write the fast software. It's very sad. It's a very sad state of affairs. Okay, so did we just compile and run the game? I don't know. The rant like cleared my L1 cache. So I don't remember. I guess we did that. And then I'm going to run the tests. Most of the third world is running on old crap. That old crap is amazing supercomputers that are incredibly fast. You have no idea how fast those so-called old crap computers are. They're crazy. They're like modern miracles. They're insanely fast. M1 cache. Yeah, out of M1 cache. Okay. End of rant for now, maybe. 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 All right, so now what? Do we check in or do we keep going? Let's just keep going. I feel good. So here, oh, go to true. Yeah, see, these are like easy peasies. If we mess up, then it's kind of clear what we did wrong, hopefully. Famous last words, right? Like, this is just pretty straightforward. Oh. Okay. Okay. Are we now out of low-hanging fruit in this file? That might be a time to check in. I mean, we've still got a fair number, but yeah, let's just do that because that's going to be basically everything of that form. So now we can go back and hit the ones that are in data structures, which is going to be the same thing we just did, but changing the data structures. Are we doing the machine code translation for x64? Yes, if you use the x64 backend, yes. But it doesn't do a particularly good job of that at this time. In fact, it does a quite lazy job of that at this time. Not, I mean, lazy is the wrong word, but yeah. Okay, so we're going to check this in. Commit, removing more, get instruction by index. The end. Next. Okay, so we've got some of these. Let's look at some of the data structure ones. Get instruction by index. This is for the patches. These are bytecode patch. And oh, we get these off a while or in each. Is bytecode patch here? So these again represent, they're not there. Oh, they're in ast, right? Because no, in general, yeah. So these are like, again, if you have a continue in a while loop or something, it's not really going to know where to go. So we just patch them at the end. So we need to make sure that this PC, so we get the patch list here, right? And then we come down here and we loop over it. And there's actually a thing that tells us which slot we want to poke on the instruction, right? But the PC, I believe, is only... Yeah. And so these are like patch to start of loop means maybe it was a continue. Patch to end means maybe it was a break. Or no. Patch to start of loop versus incrementer. I don't know. Patch to incrementer is a continue, right? Because you need to bump the iterator. Patch to end is a break. Patch to start is what you might emit yourself at the end of a loop, but I wouldn't expect us to use that. Indeed, we don't. You know what? RIP. Because all the code that generates loops like knows where the start of the loop is, because your output, yeah, it's all good. All right, so here we're gonna say that instead of the PC, just the bytecode instruction is gonna get stored on there, right? So we're just gonna say that it's BC instead of PC. I don't think we need PC for anything else. No, we don't. So this is going to say BC, BC. I don't even know why. Why are we even initializing these? Okay. So patch.bc is BC, add patch. Because it's C++, we have to change a lot of things like this over here. And then having to calls add patch. Now we've given ourselves a little job. Oh, there's only 2 add patch. Right, because we're in the loop control. Right. So emit loop control is where we go for like, you know, break and continue and all that. So patch inst. Just put the BC. BC's quest for tires. We talked about BC's quest for tires last time I was editing this and doing a lot of BC stuff, didn't I? Didn't we? Etc. Okay. Let's just get rid of this for now. Okay. Syntax error does not compute. Error. C++ does not compute. Okay. All right, well, let's see what happens there. Boom. Does it blend? Will it blend? Has it blended? Great. Okay, so let's do one more. Not that one. Okay, completed address uses. Same deal, right? Incomplete address uses. This is going to just be... oh, well, we define BC right down here, but whatever. Incomplete address use. All right. So address use. You know what? Okay, let's not do this. All right. Oh. Oh no, because I was going to say, oh, we're going to have to actually look something up, but we don't because we emitted it right here. BC with incomplete use and that BC is BC with incomplete use. Isn't that great? Isn't that great? Yes, it is. Okay, great, great, great. Then here, get it. No. This is use.bc. Okay. This is a pointer now because it's C++. We gotta turn, like, first it starts out as a little seed, a tiny seed, and then it grows into a mighty arrow. Uh-oh. Uh-oh. Oh yes. Oh yes, you can't just do that without this. It's dangerous. It's a dangerous Mario. It's a dangerous Mario. Okay, I screwed up. I screwed up. What? I don't even remember this one. Did I like screw up something else that messed with? I knew I should have checked in. Dang it. Oh, no, you know what? Because if we had this happen once, I'm just not going to trust anything for a second. Like, the likelihood is this is my bug, but, you know, once you start suspecting... Okay, yeah. Yeah. Okay, just wanted to make sure. Let's see if an assertion... Like, I don't understand what I just did. What did I do that had anything to do with that? Now it's cold. Yeah. Oh, it's asserting... oh, it's in set comment. Oh, no. Okay. That actually... Remember how that's defined to do nothing in release build. The variable BC is used. Okay, that's it. That's what I did. Is oh God, it's the same, guys. Okay. I didn't even recognize the same code that I was just editing. First. Second, I'm dumb. So I just assume, yeah, okay. That, see, I wanted to use a different, yeah, we're passing this out. I just look at the code when you program, okay. There's no such thing as code that's completely invisible. There's always little differences, right? If you watch the code with your ears, there's just little differences. Okay, so now we're going to check in. Further removal of get instruction by index. Let's just take a look at how much we got left. Not too bad. Not too bad. Now, I can't believe I made all these that fast. I guess some of them were search and replaces, weren't they? Yeah. Okay. What do we think? Anything not in bytecode builder is going to be like doing loops and stuff, which is maybe, you know, pretty simple. But before we go to that, like we can do all those at the same time or, you know, neighboring each other and be doing sort of the same thing. Okay, that's right. That's legacy. Okay, that's the switch statement. We could do that one next. Because there's going to be several right there at least, right? So that's switch statement. This is also, what are these? And that's four out of 6 is the switch statement. And then this is a loop. So we're doing the switch statement. All right. Is that an ast? Go to if false source. Okay. Struct int space struct bc. Okay. Oh wait. No. Not those two. Okay. And then these are nully poos. Again, it's not that important because, yeah. Okay. Go to if false source equals this ting-tangler right here. I remember writing this code, man. Ugh. Actually, let's do this. Okay. That's it for that one. What was the other one? Go to after body source. It's like aftershave lotion. After body lotion. After body lotion. After body lotion. It's not the rocking of the boat, it's the motion of the after body lotion. I was just sort of on autopilot zoning out there, so maybe I messed something up. Who knows? Who knows? Who cares? It blends. So we're going to check that in, I think. All right. Because we're down to legacy and then loop. So, and this one, I think we're going to want to write a new implementation and then assert that the two are return the same answer. But that's less important, or less I don't know. I don't want to do that one first. That's all I'm saying. I want to do some of the loops down here. Like this is the one that runs compile time execution. So that's kind of important. And yeah. Remove more get instruction by index. Period. Bam. Bam, bam, bam. Okay. So here, the old loop is like, look, the program counter just goes forward. Oh, this one's going to be kind of annoying. We're going to still need to have a get instruction by index when we branch. Yeah, okay, this is going to, here's where things can go wrong. So our job right now is actually just to get this out of the main loop. We don't want to run this once per instruction because that's stupid. We're going over the entire freaking linked list every time. What we want to do is we want to know the current bucket and then the index within the bucket. And then when we go off the end of the bucket with forward instruction motion, which is normal, we'll go to the next bucket and reset that index. And when we branch to an arbitrary place, then things are going to happen. So now, okay, we're starting to do non-trivial things. See how we set record program counter directly here? Let's make a thing where we say you're going to branch, right? We're going to make, again, a layer of abstraction, or not exactly a layer of abstraction, but just a function that you call to set the program counter that does non-trivial things. And a mistake that you might make if you're programming and you wanted to do something like that is you might not remember all the places that program counter used to get used. So again, the thing that we are going to do is break that. And in a strongly typed programming language that requires declarations for all identifiers at compile time, again, this is a very, very powerful thing. You just change the name. Now, nobody will compile till they use the new name. And that means that you have to go to all the sites of the old thing and change it. And this is a very, very, very great power that a lot of people using some of these other languages that they think are so great, they don't have that power. Not my fault. Not my fault they gave up their superpower that we've had since 1960 because they think it's cool. Okay, so we're going to make a thing called set program counter. It's going to be inline. Actually, all of this is in one file, so no, it's going to be here. So set program counter is going to take bytecode thread and the new PC. You're going to make that S32 because we're being specific. And this is going to say, do we have the record in the... call record, yes. Thread arrow, the seed grew up into a mighty arrow. Record arrow, new program counter equals PC. But while we are doing that, then we will say get instruction by index. We're moving it. We're adding a get instruction by index, which seems bad, but this one runs a lot less frequently than the other one, right? And this one might stay for tonight. Get instruction by index. Do we have the byte code here on the call record? Yeah. Record, arrow, byte code, and PC. And we are going to say okay, we want to know the bucket as well, because that's the thing. We want to know the instruction bucket, and we're going to make that a third argument here. So we get the bucket. Unfortunately, this is C++, so you can't have more than one return value. Even though they're all proud of how amazing many features their language has, it doesn't have this one. And so now we have the bucket, and then I guess we will store the bucket on. It's a little bit scary because, well, when we go to the loop, it's a little bit, yeah. So record current bucket equals bucket. We could have just done that, but okay. So now get instruction by index is going to take a pointer. It's going to have a default value of null. Okay. If we get here, if bucket return star bucket return equals bucket, that's all. Wasn't multiple return values added? I don't think so. Were they? Do I not know that there are multiple return values in C++ now? How does it work? I stopped paying attention a little after C++ 11, honestly. Byte Akade. That's like some dialogue from Twin Peaks. Byte Akade. All right. Current bucket is not a member of call record. Okay. Okay. We're going to have to set that to something non-null in a little bit or we crash. Watch me forget to do that. Okay. Anyway. So this is... What are we using PC for? Okay, this is just, we're just commenting this stuff out because, all right. New PC, set program counter, set program counter, thread new PC -1, bro. All right. I'm not sure about this -1 thing, but I'm going to stick with it for now. Okay, 2433. That's in our loop that we're trying to do. And then 2451 is later in the loop. Okay, so now here's the thing. See, this loop used to implicitly update the PC. Like if you jumped, it would get the new one. So maybe I'll just keep doing that for now. And then if we're worried about speed, we'll do it later. All right. All right. So on the entry, I'm going to say assert record current bucket not equal null. And again, watch me forget to do that. It'll be amazing. Let's do debug build just in case. So asserts go off. So we get the bucket and we get the PC. And so here, let's do a temporary, because we just want all this stuff to work, and then we'll speed this up even more. So instead of get instruction by index, we're going to say, you know what we don't have? We don't have on the bucket the base index. The ace of base is not on the bucket. Here's even what we can do. Let's not even worry about the bucket yet. We're going to leave this here for a second. We're going to say instruction bucket lookup bucket. We're going to get this, and we're going to assert that lookup bucket is equal to current bucket, right? Or bucket, right? That's this bucket up here. We're just going to assert these are the same, which again means that I can take this out and use that one if that's true, right? Which our goal is to get to the point where that's true. Okay. So now we run instruction with the BC, search for quest for tires, and do some other things. Okay, 2458, program counter. Okay, we need to advance this. Now again, the problem is, I don't know if we actually need the integer program counter like this, but we're going to maintain it. We don't know. Remember when we did the lookup, the get instruction by index, I was like starting at the first bucket and decrementing the index every time, which was a nice trick at the time. But it means that now if you just have a pointer to a bucket, you don't know what instruction indices any of those guys in the bucket are, because we didn't store that anywhere. So let's put it on the bucket. Are there any questions about, very on-topic questions about what I'm doing right now? Very on-topic questions. So on this bucket, we're going to say S32 base index. I don't want to use the word base because we use that like for some other stuff. Like I like to keep my namespace in my head orthogonal. First instruction index. I don't know. Yeah, something like that. So when we make a bucket, we have to do that. Make instruction bucket we don't really pass the byte code, So we're going to do this. Okay, and then this is bucket this plus instructions per bucket, right? And then, because that's the previous bucket, and then here, the first bucket, it's 0. How nice. Okay. So now that we supposedly have that first instruction index, what do I do with that? I say record program counter plus plus if record program counter is greater than or equal to bucket first instruction index plus instructions per bucket. It has left the edge of the bucket. Actually, this isn't even what we want. This is like this check and this check are kind of the same. I don't know. Okay. This is new program counter, right? And it's not actually instructions per bucket because we could have an empty bucket or somewhat, right? It's the count. We might store last instruction index on the bucket, you know, just to not have to do this while we're running. I don't know. Like this loop is way too bloated to be the compile time execution loop. So we need to deal with that at a separate time sometime. Okay. Combine this with the bytecode num instructions check above. I'm a little confused. All right. Anyway, bucket equals bucket arrow next bucket. So this is annoying. Actually, that's not awful if we put it in there. I don't think it should need to be out here. So this just puts us in the next bucket, and we're not really storing index within bucket, which we could have done. Like we could have done away with using the program counter exactly in this way and just had index within bucket. That would have been fine. In fact, I don't know if we need to know the program counter. Right? I don't know if anyone actually uses that. Okay, so this is even slower than before because now we're like tracking stuff and we have get instruction by index. But what we're doing is a little precarious. Again, I still haven't set this up, by the way. So now that we're clear of errors, or of obvious errors, we need to do this. So there's two places that call run loop. There's this one called run modify directive, and this makes a whole new thread and record, and I guess make record for procedure. Set up. Maybe this is the right place. Empty bytecode, record actual running lambda, record current bucket equals actual running lambda. No, record bytecode. First bucket, spam. Bam. Okay, that's push procedure. And then continue bytecode, actually, it should be there, just like with the program counter. So maybe. I don't know, guys. What's the probability that this works? I'm going to say 17%. 17%. I don't see any questions. 50%? Yeah, because it works or it doesn't work, right? Okay, okay. Here's what we need. Here's what we need. You're new to the channel, so am I. I'm quite youthful. I turn 20 next year. It didn't work. Well, our assertion went off, which is probably good. Probably. Let's see. Let's see what, like, it's good that we put the assertion there so that we weren't confused. All right, so look up bucket. PC is 202. We could have just asserted here, by the way, that like PC is in the, so 128 plus 64 is 192. We know what that is. So I think we somehow did a branch that didn't do the right thing. Or no, oh guys, no. Okay. See, this bucket is like invalidated when we run a frickin' instruction. Anyway. So like what we want to assert is it's equal to record current bucket. This is really bad and slow, but whatever, like we're going to figure it out later. It's been bad and slow the whole time. We're not really making it any slower than it was. Where were we? Where's our assert? There it is. So we want to assert that actually. Because a branch will set this if all is right. Okay, it still didn't work. Dang it. I should have actually checked that, because I could have looked. All right, so bucket is this. Record current bucket is the same, but PC is probably the same PC that we're just looking at, 202. Yeah. So what I feel like is I want to look again at set instruction or set program counter, right? Let's just see if this is a branch. Conditions, PC is equal to 202. We might have a lot of branch 202s, but let's see. Well, that's not how we got there. Record new program counter is equal to 202. You know what I really should do is look at the code that is causing this, but we'll see. Oh, that's, we do increment it to 202. Bucket first instruction index plus bucket count, that's 128. What? Did it get set back? Was it daylight savings and somebody set the bucket back? Like what? What? Okay, so first of all, if it's, what I meant to do was I'm doing greater than or equal for safety's sake, but it had better be equal, because if we get here, we better have gotten here by this thing incrementing us out of the bucket. So we want to go assert this, but double equal right there first. And so that'll trip probably earlier than this thing. But I also kind of, yeah, I don't know. So now, and then when we get down here and we do the if bucket, I just want to assert again is greater than or equal to this, and then less than, it had better be in the range. Now in the long term, this might be untrue if we ever leave an empty bucket, but we have no way of making empty buckets right now, so we're not going to sweat it. All right, so this probably still asserts. So we somehow got past. I don't get it. But let's take a look. So we're at 102. How, like, we must have branched, right? Oh no, we got in here from a continue bytecode, guys. So maybe I'm doing something weird in continue. So continue bytecode is like the one where we just call run loop again. What if I do this up here? I'm going to, again, just copy this for a second. I'm going to put a no check in. And I'm going to do this assertion that when we come back into this, I'm going to do both of these. When we come back into this function, this really should be actually, yeah, leave that. All right, that's probably going to go off. Line 2467. No, really? Really? Am I, you know, I'm probably just not looking at the code. Okay, so we have a situation where we're supposed to be going one step by one step, but we somehow get to 102. We're supposed to go hit this at 64, right? So I really suspect this is a job. Okay, let's look at the code for a second. So we have this BC. This is actually, this is from before. Yes, okay. So we jumped from PC 47, right? Because that's before run instruction. So PC 47 is a jump instruction, and it jumped us to 102, but somehow in a way, oh guys, I'm stupid. Remember when I said this value is not valid after we do things? Remember when I said that? Sometimes people say things, but then the way they live their life is not concomitant with the values that they express vocally. You know, like they say clean your room, but is their room clean, and so forth. And so I basically did that here, right? So what I'm saying is I basically did a bad thing. All right. All right. So it blends. It wasn't that hard. I was just stupid. Like the code was even basically correct. I was just stupid. I knew what the problem was and I still didn't do it. All right. Let's get rid of a few things here. Get rid of that. Get rid of like all this. Like this runs once per instruction. It's really too much stuff. So like I said, we're going to have to come back later. But remember this though. Okay, hold on. Before I get fancy removing this, let's just make sure the tests all pass in release. Okay, so that goes in release. That goes in release. Okay, did I miss questions before? Because I asked about questions and then I just went and looked at the screen. And so I looked at this screen instead of that screen. That happens sometimes when I'm programming. So, you know. Okay. That is one of the main loops, and you know, I should run that in debug because the whole or part of the point is that assertion that would tell us if those things are not equal ever. Yeah. All right. Nobody has any questions. Nobody cares about me or programming. Okay. Gonna get rid of that. And then, so because this assertion is passing, we now can say, get rid of this evil get instruction by index and all this. And BC equals ampersand bucket arrow instructions PC minus bucket first instruction index. All right. Actually, let's just go for it. We can add an assert if we want to, if this doesn't work, but I kind of feel like it's okay. All right, that all passed. And that's all passing. Ding, ding, ding. Ding, ding, ding. So you see, we've had a couple of... Okay, so to recap what this whole stream has been about is we are transitioning the way that these bytecode intermediate language instructions are stored in the compiler, the basic data structures that hold them. It went from a large contiguously packed array per procedure into a linked list of little smaller arrays. Right? And that's just lets us do more things with them. and makes their pointers memory stable during the window during which we care about them being memory stable, and so forth. Now, loops like this one that we were just editing sort of assume that things were packed contiguously, and what we're doing is modifying them to accept things that are not packed contiguously, all right, which is all good. Now, it's mostly gone very smoothly, which is great. This will be a YouTube video probably, but there were occasional times when I got confused, right? But because we were sticking close to like the ISO surface of a working program, we never got that confused because the number of things that could have gone wrong was pretty small the whole time, right? Imagine that we had done this the way I might have done it in the past and just said, you know what, today's the day when we're changing the data structure, and you just change the data structure and you're like, oh man, this means I have to change all these things, and you just change all those things. There probably would have been at least all these bugs at once, and probably more because you're juggling more balls at one time. It's easier to drop a ball, right? So then when you try to debug those, you have no idea what the problem is. You're just like, oh man, it could be anything. And you know, sometimes it's clear, but sometimes it's not so clear. So this is a method of reducing debugging time, among other things. And I just want to show how I do it, right? Are all the rants going to be included? Yeah, I'm just going to upload the VOD probably with, you know, empty space cut off the beginning and end. I don't have time to edit YouTube videos. How are you kidding? Okay. So this is great. Like I said, I don't think we're going to get to tonight, if only because I want to get sleep eventually. We're not going to get to completely removing get instruction by index, but I think the number of calls to it will be very small. Like we still have it in the branching case, for example. But again, I think the right way to solve that one, earlier in the stream, I was talking about having a level of indirection for branches so that you could move the instructions around and not have to like constantly be backpatching everything, which will drive me insane and be very error prone. And so once you have that, once you have a table of like branch destinations in your bytecode data structure, I forget why I was saying that. What is it? What was I saying right before that? I turn 20 next year and I have an excellent memory. I totally lost my train of thought of why I was saying that, but I was saying it for a reason. How wasted am I going to get on my 21st birthday? That's like way more than a year in the future. I don't think that far ahead. I do not think that far ahead. Anyway, oh, yeah, but okay, it was about get instruction by index being used in the branching, right? Well, when we have this table of indirection, that probably stores the actual index of the instruction along with a little more information like what's the bucket, right? Because it's okay to store a little more information because most instructions are not branch targets. So then we don't have to use get instruction by index there, but that requires that other data structure, which will be probably a topic of a different stream. So we're not going for 100% elimination of this right now. We're just going for mostly. You're 21 and can't think more than a couple weeks or two out, smoke less pot. Okay. I think we check it in, question mark. Like we've got a few more loops to do, but they're honestly not that hard. So most of the other loops are just iterate straight from front to back with no branching, which is easy peasy, right? Anyway, this was the loop that I was scared of. And so it was good that I did it before I got too tired from being late at night. Okay. Rewrite bytecode runner loop to know about the buckets, right? Before it didn't know about the buckets, it just treated it like it was a contiguous array, sort of, using that get instruction by index abstraction, which was very slow because it was just over the linked list every time. You don't want to do that. You don't want to do that. Okay, next, I feel like x64 converter. Because like, yeah, let's do that. Output machine code. Well, instead of passing an instruction index in here, do we need that for anything else? Yes. Okay. So we're just going to pass both. We're just going to pass the BC right here. Get rid of that. Right? Okay, so output machine code. Why do we have two of these? Oh, because of the emit debug info. We set these instruction addresses. Okay. So I'm just going to I don't like this instruction addresses thing. Like, I guess we kind of need that. I want to revisit that later. Anyway, so we're just going to say auto bucket equals lambda bytecode first bucket while bucket equals bucket arrow next, etc. Okay. Int I equals 0. This is a little bit annoying, but it's totally feasible. Actually, we could do it this way. And again, we're going to do an add in here. Output machine code lambda byte code I plus bucket first instruction index and bucket instructions I, except I believe this one went here. Okay, so like that. Oh yeah, don't delete the bucket equals bucket arrow next. So this, and then we got to copy pasta this for now. So we do this, and it's just we're just going to do this. And this is instruction index. And so is that. Whoops. Fat finger. All right. So that's slightly annoying, but it's fine. Except it's not fine. Oh, it's next bucket. Sometimes I decide to put these silly names. Oh. Wait, it's a different output machine. Oh, geez. Oh, geez. OG. I'm the OG gangsta. Wait. I thought it was the same. Let's take a look. Oh, okay. First of all, I didn't delete that loop. That would have made me very sad. Oh, that's probably the only problem. right? The problem is the problem, as Mike Acton has said in the past. Yeah, the problem is the problem. So that's great. That's great. Bam. Does the transition make compilation slower? No, probably not. If it does, we'll deal with it later. I mean, in mid-transition, we were a little slower. You know, it's hard to tell because when you're streaming and it eats CPUs and stuff, I believe we've gotten slightly faster than we were at our slow point, although once in a while we post big numbers like this. So we're like between 7.4 and 7.8 toward 7.4 most of the time. And that's all right. 8.1, I mean, you know, you can't tell. So the deal is, though, that, you know, we're still getting rid of these get instruction by indexes, which are pretty slow. And then, well, in the end, we will profile things. And if anything is taking a noticeable amount of time, we will ask why. I mean, we won't do that tonight. But yeah, no, I don't expect one, like, even though, like, people who've been watching the stream know that the numbers we've been posting lately are in this neighborhood anyway, right? It's just they're barely slower enough once we added this get instruction by index thing to notice, right? So once we remove it all, again, it'll like be a barely noticeable speed up. We would hope for a barely noticeable net speed up from not copying bytecode instructions so much due to array expansion, but I didn't even bother to profile whether that was a noticeable impact before. And it may not have been because we did do array reserves with that heuristics based on procedure size. So, you know, really the goal of this is more structural. It's to permit us to start thinking about running optimization on the intermediate representation, which we really didn't want to do with the previous data structure, right? And we still need to do a little bit more after this, right? Like I was saying, have indirection for jumps. But that is the real point of this. And we don't want to sacrifice speed to do that. You know, but we're not, this is not about optimization as a first priority. It's just, if we get some optimization, we're happy. We're always happy to get some optimization. Okay, anyway, so that was remove get instruction by index from x64 backend. That was easy. And then there's going to be, I guess there's 2 loops like that in the LLVM backend. I don't exactly know what the deal with that is, so let's look. Get instruction by index, emit disassembly to IR. That's again the same deal. It's getting called with instruction index, and then emit. Okay. Yeah. Wow. Wow. Okay. So we need a previous instruction and a current instruction, right? So you know what? One step at a time. We have a previous, we do this, and then previous equals BC, right? And then instead of doing this, we just use previous, and we do that, right? And we'll just make sure that works. So we got rid of one of them. We got rid of the get instruction by index that was here for previous, and then we can attack the one, the other one, the current. The current. You can't just subtract from the pointer because, again, when you cross a bucket boundary, Then you cross a bucket boundary. All right, well, that was LLVM compiled. Is compilation speed proportional to lines of code? No, I mean, that's probably not true in any compiler. Like, in computers, there's some stuff that you just can't really do faster than n log n, or maybe n log n, right? Something like that. Like, things that we do on computers, if they're non-trivial, generally are slower than n, where n is, for example, the size of your program. That's true. That's just a fact of computer science. So I don't think you could ever expect compilation speed to be proportional to lines of code. That's an unreasonable expectation. I mean, exactly. You could expect it to be approximately proportional to lines of code if there's good engineering involved, but it's probably impossible from a computer science standpoint to be exactly proportional. You know what I'm saying? Okay, let's run the tests with LLVM. That was a pretty milquetoast change. So now, while that's running, we will look at this one. This is, well, we need this same kind of a loop, right? So here we go. Here we go. So we're going to say instruction index equals I plus bucket first instruction index. And then I mean, we could use a defer there. Okay. We're going to just chop this and put it down here, I guess. And there. All right. BC star BC equals and bytecode instruction sub I. You know what else we could do? I forgot to name new program counter. Back to program counter, which is the other half of the secret rename technique, is that you rename it back at the end of the old name. Okay. So these are some other cases in which we create a block, I guess. Okay. So here's our within bucket loop. Okay. I mean, it seems reasonable. And then after this works, we have to pass this into what? Into, I thought we called something. Don't we call emit disassembly? Am I, oh, that's just a block creation or something. I don't know, guys. It's a little bucket. This is bucket. Why did it think? Do we have a control M? Whoops, no. Yep, right there. I don't know how those get into the files. I, to this day, don't know if it's Visual Studio or Emacs doing that. But whoever it is can cut it out, please. Cut it out. All right, I screwed up. I done screwed up, everybody. What did I do wrong? The previous part is probably fine. Oh, because it's I. I is the wrong. We change. See, you shouldn't do that when you're doing this. Like I used to mean something else, and now it means a different thing. This is instruction index. All right. Any other. So this is our I. This is our I inside the bucket. That's fine. And I don't. Let's just try release again. Yep. So again, if you can know what, as soon as there's a problem, if you can know what the problem is before opening a debugger and sitting there and scratching your head for an hour, saves you a lot of debugging time, right? Just like look at what you did, look at what the changes were and what you might have got wrong. And then it also, though, a lot of that is just experience. Like you've done it so many times that you're like, your brain just knows how to see the problem. Which again is something you build up with reps, right? You got to do the reps. 1, 2, 3, 4. That's how many pull-ups I can do. 4. I'm almost up to 5. 4 actually pull-ups, right? Do the reps. Which is why the Hacker News people who say you can't possibly program for more than 3 hours a day are never going to be that good at it. Sorry, guys. You're not doing the reps. All right. So that's pretty good. We're not done with this file. We have at least one more, right? Get instruction by index. Yeah, from here. And we're just going to do the same thing we did before. BC, arrow BC. We just pass it in. All right. Do we need bytecode? Yeah, we do. Okay, so emit disassemble. Hopefully there's only one call. Site to IR. Yeah, that's the only site. So we're going to put a BC here. This is a gnarly loop. We might want to factor this. Like, yeah, there's just, I don't know. No, we won't. Okay. Same thing, bro. Same thing. All right. I almost would want a function. Like if this were in the programming language that we're developing, I would make like a macro, like a hygienic macro where you pass the body in, maybe. Or no, I would just make it a data type that has an iterator, right? Or something. But it's just so painful in C++ to do these things that I don't do them. I just would rather do this. I would rather just do it explicitly. All right. So now I am going to learn my lesson from last time, especially because this is bigger. And we're going to go for j. J equals 0. J is less than bucket, right? And we're going to do instruction index with j so that if we leave any i's left over, we see them. We see the i's. So we do this, and then we do some stuff in here, right? I could name instruction index I, but I'm not going to do that. I'm going to explicitly change them to, okay, wait, this was outside the loop. Let's put that outside. All right. So, oh, all this push and pop instruction index. Oh man, that's all going to have to get rewritten. I'll tell you what. Oh my God, but not right now. Not today. Not today. All right. So maybe I will. I gets used a lot, but let's do it. So we're going to go query replace. Like I, you can't query replace I. It's in like every single word. That's in every. You know what? I should have like a match. I'm sure in Emacs there's like a query replace on specific identifier without having to do like a gnarly regex, but I don't know how to do that. I have a reduced instruction set computing approach to Emacs usage. Whoops. So it's fine though, because we didn't name something I. The compiler will tell me when I miss something. I hate all this push and pop stuff, man. It was that some other code was that way, and I rewrote it to be totally different. Yeah. All right. Do we already have a bucket? Do I have a double declaration of bucket? Well, oh, these loops are in the same file, guys. I didn't even notice that fact because it is big. Or in the same function, not the same file. All right, next. It's called next bucket. We knew it. We knew it. The stream is not live. The stream is not live. Meta X replace only what I want. Yeah. Yep. All right. Get instruction. I feel like that's most of it. There's this loop that we were talking about. There's this one, which we said we're not going to try to replace tonight. What's this one? Okay, this one can be rewritten. This is just the same as the loops that we've been doing. It's just being called once per instruction index, and we just do the same thing where we put the loop outside. Okay. Let's run once in debug builds on the game at least, or I guess on the tests. It's just debug tests with LLVM backend take a lot of time, but you know what? We'll do it. We'll put in the time. We'll do the game. Not with x64. No, 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 with LLVM. Any questions on what exactly is going on? We're nearing the end. We've done pretty much all the hard, scary parts. These problems have been... Oh, wait. I wanted the game. These problems have been solved. We just found the few patterns that we needed to implement that worked, and we're just repeating those. Does the bytecode builder do any pushing, popping of scopes and insertion lookup of symbols, or is a simple table filled out earlier? No, that all happens in the bytecode builder, because prior to that, your representation is just the syntax tree, which is like not a place, like there's not a symbol table there. There's not really a symbol table in bytecode builder either, you know? You know? Okay, so this seems to be working pretty well. And we are in the game. Let me get some water. Any more questions while we're waiting for these tests to finish? Hey, it finished. Nobody has other questions. Nobody cares about computers or things. Okay, so, right, we had one of these in. Oh, we got to check in. Remove get instruction by index from LVM converter. Blammo, baby. And, well, let's grab our loop again. Let's go to bytecode runner. And we got one here, and we're just going to do the same thing. I'm going to pass this. Let me paste that and delete this, and then get this. Okay, print this sass. Okay, and simple. Print disassembly of BC instruction index. Let's just grab this. There, get rid of that, get rid of these. Don't. Oh, because it's C++, you can't, okay, guys, you can't just do this in C++. You can't just change the function to be how you want it without filling out all your forms in triplicate, okay? It's just, and the way that you know that you didn't fill out your forms in triplicate is you get like infinity number of senseless errors that have nothing to do with anything that you were doing. All right, well, I still had some real errors. Oh, yeah, because we didn't have lambda. Because we don't need lambda because we have bytecode, guys. Guys, whoops. Arrow is not a unary operator, guys. Okay. I used autocomplete. All right. So that's, I mean, that's not honestly being called by anything. That's a debug function that I basically run once a year. So I'm not even going to worry about it. I just wanted to do the changeover. More removal. Okay. So now we're down to basically this loop. Oh, no, this one. Oh, okay, this one. We're going to leave that one for now because this only runs once. It's like once per function, and I'm not sure what's a better way to do this. And it's index 0, so it won't iterate over all the buckets anyway. It'll just be the first bucket. And honestly, this is a stupid hack to begin with that I would rather figure out a better way to do this than this stupid hack anyway. So we'll leave 2 of these tonight. We'll leave this one, and we'll leave... oh, I forgot about flag as branch targets. We're not done. We're not done. Okay, this one. This is the one. This is the one where honestly we might leave it till tomorrow. We'll see. Because I could easily mess this up. Actually, no. So like later we might want a hash or something, but right now, oh, it's going to be easy. So what I was thinking of before was, what if the bytecodes have, different numbers of instructions in each bucket and all that. But like, honestly, if you have either we're calling this pre-optimization, which maybe we are, because why would you go through all the trouble of optimizing a function and then seeing if it's a duplicate of another function? like you did all that optimization time. That doesn't sound good. Or what we really should be doing is storing a hash of the original bytecode. So I'm going to make a comment of that. Either way, it doesn't matter right now, because if the buckets have different number of instructions, then they don't match. And that makes this function easy to write. So I'm not going to make a duplicate of it. Yeah, no, we will. Oh, you know what? New program counter. We need to change that back from new program counter to program counter. Replace all. Lol. Okay. Anyway, back to here. Oh, that's been replaced by... Okay. There we go. 5750. Van Halen's new album, 5750. So this is going to be called bytecodes match old. And we're going to call a thing called bytecodes match new. And we're going to put no check-ins on these to remind us to delete one and rename the other. And so, well, this is all fine, exactly the same. And we're going to say while bucket A, well, if not bucket B, that means we ran out of instructions in B, so return false. If bucket A count not equal to bucket B, count return false. Okay, bucket A is bucket A, next bucket. Remember, it's not called next, it's called next bucket. Bucket B, bucket B. So what goes in here? Well, this loop. Bucket A, arrow count I plus plus, BCIA equals ampersand bucket A instruction sub I, and then bucket A count and bucket B count are the same, and voila. Doesn't seem very hard, right? Okay, we're going to need a debug build because we're going to want to assert that these are the same. So when we call bytecodes match, we're going to say bool match equals bytecodes match new of these things, and we're going to assert match is equal to bytecodes match old of the same things, and then we check it and trust it. All right. See? All right. So now we're going to want to run debug. Debug build. I'm getting tired. Do I look tired? I feel tired. What kind of compiler am I making? The kind that compiles. Look, we just compiled and our assertion didn't go off. And honestly, so that function, this check for duplication is done for polymorphic output. And let's make sure it's actually still called. We might have disabled it at some point. No, I mean, we use it. Oh, that's duplicates. This is duplication. Yeah, we use it after we polymorph a function to see if it's the same as another function. We should do that differently. But actually we do. This is like the second tranche of deduplication. The first one is just based on argument types. So we're good. And so let's run the tests with this. And I'm just going to run in x64 because it's faster than LLVM, and all of this stuff is the same because it's prior to the backend. So this stuff doesn't matter based on the backend argument. Okay, this is great. That was the loop that I was mildly scared of, but now I'm not scary of it anymore. All right, so we're going to get rid of this. Get rid of the no check-in. Get completely rid of this. Get out of town. And then you just do this and do that. See, you just write a little bit more code than you needed to write, and then you delete it later. Like, some people don't do, I mean, I guess I didn't do that originally. Like, I used to never like writing more code than I had to because, you know, it's hard, man. Writing code is hard. It takes effort and all this stuff. And it's like, yeah, but you could save yourself so much trouble by just doing a little bit more. Like, just a little bit more. Because if I had messed up that function, everything would still compile correctly. I mean, I could somehow mess it up such that it would crash, but if I messed it up such that it only returns the wrong result, then things would still appear to compile correctly. They would just have a larger code size than they should have, right? And so we verified that that wasn't the case, etc. Sort of. I mean, we didn't verify that our verification was correct, which you would do by like intentionally returning the wrong result, but like I said, that's going to get rewritten eventually anyway. Great. Yeah, let's make sure the game compiled. I don't remember. Is that it? Is that all of these? Now we still have the flag jump target thing that I forgot that calls this. But aside from that, get instruction by index. Yeah, so we have this one that I said we're going to leave. We have this one, which we're not going to try to do tonight, right? Because that requires a layer of indirection. This one is in flag as branch target, and that's it. This is the declaration. So we are done with this phase. So now the next phase is flag as branch target. We don't want to use this anymore. We just want to pass a BC into this. All right. Hopefully that'll go fast. We'll see. More removal. Flag as branch target. Hopefully we got a lot of these. So yeah, there's not that many. So the first pass is going to be looking for things that we can turn into flag next instruction as branch target. But you know what? I can tell that the only possible one is this, because these two are on data structures and these are the other thing. Yeah, so this is flag next instruction as branch target, but that's the only one we could do that to. Bam, right? Are we not using that? Done with, oh, we are. Okay, we use that. All right, great. So now, let's just make sure I didn't screw that up. What's it called? Flag as branch target, right? Flag as SAS as branch. Are you saying it's easier to pull back what you've done than to try to figure out what you need to do in the first place? No, I'm not. I'm saying that there's a psychological barrier to writing code that you know you're going to delete. At least I had that barrier at one point, and it will greatly serve you if you are willing to write more code than you absolutely need to, knowing that you will delete some later. It's a very helpful technique. Okay, so these three, PC for loop start, PC for loop end, PC for loop incrementer. I don't think we need these for anything except this, which means we can pass BCs in there as well. Let's see. Wait. I meant to search for, I'm getting tired. PC for loop. PC load letter. So that's the thing that we were just looking at, right? And then here is, no, we actually do need, oh, remember, we don't have loop start, first of all. Nobody ever uses loop start. So let's just delete that, right? Wait. Yeah, that's just if we were to use it. But like, nobody... Nobody cares, right? Oh, we need it for this part because it is a branch target. We could probably factor that out later anyway. Okay, we do need it though. Okay, we're just going to have both. Well, actually, for loop start, we don't need both. So we're going to go BC for loop start, and then this is going to be annoying, but right, and then all right, and then what were our overloads of this? Hold on, it's right here. Like, we don't need that index even. So like, boom. Okay. I hope I saved. Hold on. Yeah, I did. I just switched. Yeah, it's a little scary. Okay. We don't care about this. B, B, B. So those are the B's, and then the C's are down here. We have to pass both of these because we don't store on the bytecode instruction the index of where it is, because again, we don't want to have to update that. Although we might, I don't know. We might do that eventually, but for now we don't. So now also, because this is C++, you can't just do what you want to do. You have to do this stuff here. Whoops. Okay, so now the caller resolve patches. Okay, so for example, for done point, you know what? I just did a bunch of stuff. That is not really a good idea. Let's factor these out. Because like for this one, we want to do flag next instruction as branch target. But for like iterator point, for the other ones, we know anyway. Like, or we could flag that as branch, like we could say flag next instruction as branch target here. Okay, we don't need this thing to do that. And is that the only, there's going to be two, right? There's two kinds of loops. Yeah, so I think, honestly, these are gone. It has two arguments. Hope this is good. I hope this is the right way to do it. Okay. So these dunzo. So here we're going to go flag next instruction as branch target. This might be the only version that we ever use in the end. Okay, so loop top is going to go away, but I don't want to delete it yet. So loop top, done, and iterator point. So done point we just marked. So we need loop top and iterator. Iterator point. And loop top jump point. Oh, there's one there. And one there. Okay. That is great. Maybe. Unless I totally screwed it up and then it is not so great. Okay, so now our resolve patches can get rid of this because nobody cares. Yeah, that makes a lot of sense to me. Let's make sure that one compiles. The other one will complain. Oh, whoops. Maybe someone caught this. Right? Do we have bytecode? Just current. We'll just say current. Okay. Okay, so now we got to do this one in the while loop. So loop head, go to end pause, and loop head. Okay, there's only two. Go loop head, flag next instruction as branch target, current byte code. Biz. So many things. All right, so many things. So that's loop head, and then there's go to end pause. Go to end pause. Flag next instruction as branch target. This is donezo. All right. Will it blend? Apparently so. And thus I am saved from the horror of a late night debugging session to try to get all the work done. Thermostat is back on cool instead of heat. Okay, I think we check that in, and then I mean, we're basically just have these two, and that's it. That's it. Two more from the giant journey. The giant journey. James and the giant journey. Is it really 10 p.m.? It is. Yeah, we're still an hour ahead here. We're an hour in. Max Headroom was only 20 minutes into the future. We are 3 times as far into the future as Max Headroom ever was. All right. That's all I'm going to say about that. Okay. So now we've got stuff on. Oh, no, guys, this is. I said that it was obviously on a data structure, but no. No. No, 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 no. Because it's the current thing. Okay, this one though. Where does this get set? You know what? Let's kick off an LLVM test while we're, because I'm getting a little paranoid. It can't be this easy, right? So we're just going to run those. The reason I'm doing that is LLVM is doing slightly different things with the basic blocks. So if we fail to flag a jump, it probably doesn't matter, actually. Anyway, like debug info we should test debug info at the end. And then if it's screwed up, I'll just go to bed and we'll fix it later. Okay. Skip condition location. Right. We don't want to necessarily flag this as a branch target though, right? The problem here is we don't know what the next instruction is, or even if there is one. Like, what we could do, we could just make a little function called get the next, you know, get the next BC. But we have a weird case where, like, what if the then block isn't filled? Then this has to be it, right? Which, when you're using the integer index, naturally happens because it ends up being the index of this. But if you're using a, oh, no, actually, it would. Okay. Okay, we're going to do this. We're going to do this. Skip condition BC is get next BC. This seems scary because what happens to this pointer if the block is empty? If the emit block below is empty, well, the instruction, the go-to instruction below fills it. This is fine unless for some reason we get rid of that. So volatile, we need an instruction to fill that slot for sure. And we'll just put that note right here as well, so we know those parts of the code. It's a way of like visualizing a constraint between these two little parts of the code. Okay, so I could put get next BC. Oh, that's how about, like, you could even imagine it being an optional argument to this to give you not just the integer but the bytecode pointer, but really we can put it next to oh, we never inlined the instruction function. I kept saying remind me about that and we never did it. Guys, remind me about that. Not yet, but in a minute. So here it's, remember this whole thing. Okay. So we're going to say BC get next BC. There's always money in the banana stand. There's always room in the next bucket. Did I just delete the word always? What? Guys, my brain is fading fast. I will tell you. There's always room in the next bucket. So we just return the same dest. Destro G.I. Joe is there. Flag as I keep doing that, guys. Current byte. We have it. Just called it bytecode from above. It's fine. It's fine. Okay, so we don't have skip condition BC. Okay. Okay. I don't remember if I passed the bytecode. I feel like I don't. Oh, we do. Skip condition BC, right? BC's quest for tires. BC's quest for tires. Reminder on testing debug info. Yeah. I'll write them both down. Instruction. I just want excuses to be done at this point, honestly, but we'll keep going. Instruction. And test debug info. I should have tested debug info before, because if it's broken now, it's like, I don't know, right? It's something with flagging basic blocks being wrong, probably. Yeah, we'll see. I mean, that compiled. X64. Chung 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 chung. Let's also make the game. Hey, guess what? It's too cold. Did I note inlining 2? What do you mean? Do you mean, does that change any of the marking for branch targets that we do? No, it doesn't change anything. Just don't write bugs. I agree. Just don't write bugs. Just don't do it. It's like they taught you that in the movie Heathers. All right. Was that it? Like, we literally only have one call. Like, that could just be oring the frickin' thing. But guess what? Guess what goes away? This now goes. Blammo. Nobody calls it. And you know what? I'm going to be cavalier and not even run it. We're just going to check that in. Because removed the bad version of flag as branch target. We are officially done with all that. Except, again, the couple of calls to get instruction by index that are, I'm going to write that down for a different day, that require more data structure work. But by and large, this has been great. Let's make sure we didn't like spike our performance horribly. Inlining the instruction. Oh, yeah. Okay, yeah. Yes, that is next. As soon as I just look at the runtime of this thing and make sure it's still not real long. Yep, it's still basically the same. We got an 8.1. We don't like 8.1. 7.8. 8.2. It's going down. We don't need to worry about it. We're getting a lot of 8.1s right now, but it's just, that's the temperature the CPU is or something. Sadly. All right. Hopefully somebody will set you right on the incorrect assumption you just made. Okay. Yes, so the instruction function, what's your conjunction? So this should honestly just be down there. So I'm just going to cut this and go there and go there and go there. And just put a little space. All right. I mean, I sort of see why I did that, but it's not. It's not. It is not the way. When you watch The Mandalorian, they're not saying this is the way about that. saying it about other things. All right, 7.3. See, we're back in the lows. It's great. Okay, so now the other thing I wanted to do, in addition to just inlining this together, is that this whole thing is not the way. So we're going to do this at the top. And we're going to say this is going to be BC's quest for tires again. And then instead of doing like a constructor silliness here, we're just going to set it. All right, we're going to set it instruction equals inst bc index a is index a, bc index b is index b, index result is index result. Okay. And then we set line number and S. And then debug expression, which honestly, we really should get rid of that someday and do it a different way. And then we get rid of that. And then we do this. And then we do return BC. Okay, so that's all good. Except the spacing here. Come on. Clean your room. Clean the lobsters out of your room. Okay. A. This is just A and B and result. Clean the lobsters out of your room, bucko. All right. Clean the lobsters out of your room. Do I dare ship a beta after doing all this just so I can have 3 shipped betas in a row? Or do I sleep on it? I think I sleep on it. As fun as it would be to have 3 betas released on consecutive days. It's a little bit of a cheat because the last beta was yesterday morning. But yeah, I mean, on the one hand, there's a thing I want to ship to someone, but he has a workaround for that anyway. So it's not critical. There's nothing really critical to ship. Time critical. Okay, this is good. This is very good. Do we do anything else here? Oh, yeah. We don't need this stupid ass constructor anymore. At all. In fact, yeah, okay. Wait, do we have another one? What? Did I miss one? What is make instruction? Oh, that's something from the inliner that's gone. Yes, that's something I didn't write because I would not have been happy with that. Okay, great, 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 good. Good, very good. Good, very good. Good, very good. Okay. Sorry. I want to make the game. I want to make the game. I want to make the game. All right, I'm scratching off, inlining and simplifying the instruction thing. That's great. All right, so let's test some debug info, right? Let's find out how bad I screwed up. I mean, I guess we should test both x64 and LLVM, which means I should know which one I just made. Okay, there's x64. So we're just going to, oh, that's the wrong, it's the wrong compiler I just ran. Or wrong IDE. It's the wrong IDE. Are any of the beta testers making cool stuff? Yeah. Yeah. Of course. All right, so what's a good place to break? Particles. Remember? Remember we had that whole session about particle effects? What's it called? I don't... was it in part... We can do particle update. Right? Where? Sample. Update emitter. Maybe? Maybe that's a... Yeah, okay, so emitter. It's, yeah, that's got the things. But really that's not what we would expect to break. We would expect like instruction ranges to break, which would mean like, you know, if we break here, are we really there? So gravity dir is currently uninitialized. And will it become initialized when we step through exactly the right place? So there and there. Yeah. So that's good. I mean, to a first appearance, I don't know, I'm not going to do a super test tonight, but we'll do that same thing with LVM output. Today has gone pretty well, honestly. Okay, we're here, and yeah, we see the emitter, gravity dir, not initialized. Let's go here and restep. Let's open this up again. So uninitialized, and bam. I mean, what do you want? Okay, so I'm going to be mature and not ship this tonight, which means I'm done and I get to go to bed. This has been fun. I didn't know. I actually didn't expect at the start of the stream that we would get all the way here, but we are here, and I'm happy I got to do this because I've been wanting to do it for a while. Data structure changeover. Data structure changeover. Good times. Good times. Good times. Any final questions on topic, specific, technical, having to do with the programming that we did here today? We started with the entire compiler using one way of the intermediate representation being laid out in memory, and we ended with it having been switched to a different thing. I had fun. Oh, now I'm yawning. All right, everybody. What engine am I making the game in? I am making it in Code. It is the Code programming engine. Yeah, pointers to bytecode are now stable. It's unclear how stable we will keep them. So right now for that code, all that code in bytecode builder, for example, needed them to be stable during initial code generation within a particular function or whatever, which it is. Actually, it's currently stable through the lifetime of the compiler because we never rearrange that. When we start doing optimization passes on the intermediate representation, you know, you would expect to move things around probably. Now, it's an open question about whether we would like those pointers to remain constant at that time or whether we would like them to stay where they are and use those buckets more as allocation and then have like separate buckets of like actual just pointers to the dudes. I kind of don't think that's worth doing. It sounds bad to me, but maybe I could be convinced that that's better. I don't know. Why did I remove that BC constructor? Because it was useless code that wasn't doing anything. We only make them in one place, and it's much more straightforward to just assign the values. Also, I just don't like that thing in C++. Like, how many ways do you want to assign a variable in C++? The weird constructor one where you like construct the members by using parentheses. It's bad. It should never have been in the language, guys. It's just emblematic of the things where C++ spent its complexity budget on things that don't yield an accordant amount of benefit for the budget spent. So that's why I'm happy deleting things like that. Thanks everyone for coming by. I'll probably post this on YouTube later, not tonight. And I'm probably taking tomorrow off from streaming because I've been streaming long hours every day. I've been streaming like 8 hours a day or something minimum. Thanks everybody. Let's raid somebody. Let's find out who to raid. What oops concept do I use in the code? Well, I make mistakes all the time, if that counts as an oops concept. Who can we raid? Look at this channel has 700 viewers. It's crazy. It's crazy. You know, we see the same people on night after night. Those are the people getting work done, probably. Maybe. Unity dev, ask your game dev questions here. What's he making? Push-ups 50. Okay, that's good.
Yes, the 5 content fitters in Unity do not work well. They are...
That looks like a sexy game. I'm not sure. Is that the guy when we raided him and then accidentally found out it was a sexy game? Who was that? There's a lava lamp in the background. Oh boy, doesn't that look fun, guys? Oh, look at all that. Look at all that. Oh, yeah. Oh, yeah. There's not a lot going on down here at this part. So, well, we're going to go back to the top and pick someone. We can do Adam C. Eunice again. He's always fun. Thanks, everybody, for coming by. And, yeah, we'll see you later. Again, probably no streaming for me tomorrow. I won't be making the big Twitch bucks tomorrow.